Okay, Assalamualaikum warahmatullahi wabarakatuh and afternoon everyone.
Good afternoon, Miss.
Yeah.
Waalaikumsalam, Miss.
Okay, sorry saya buat kelas hari ni sebab
Waalaikumsalam, Miss.
esok saya nak, kan kita ada lagi tutorial dengan lecture kan patutnya waktu tu, tapi takut esok awak tak free. Okay, so hari ni saya buat sejam, saya plan buat sejam, nanti esok baru kita sambung lagi sejam. Kelas pagi kiranya adalah, awak nak 2 jam terus je ni. Saya tak sure yang ni habis berapa lama. Saya buat sejam ni lah nanti esok pagi sekali lagi. Boleh?
Okay, Miss.
Okay, right. For the first hour tutorial for chapter 11, so for this chapter, we are going to have 4 hours tutorial. Okay, 4 hours tutorial regarding 11.1 until 11.5. Okay, kalau yang awak ingat lagi kita belajar semalam, admin ni banyaknya dekat reactions. Okay, dekat reactions and also the naming a bit different. Dia lain sikit from the other organic compound sebab dia melibatkan the nitrogen itself. Dekat atas nitrogen pun ada substituent sendiri. Okay, so for the first question in NFTF, you need to classify the following amines as primary, secondary and tertiary and then give their IUPAC names. Masa kita belajar naming for amine, we learn 2 names. The first one is common names, lagi satu adalah IUPAC. Kalau IUPAC mesti ada prefix, parent dan juga family. Okay, itu as the basic, faham kalau IUPAC ni. Okay, so for A, here you have this compound. In your compound, you got nitrogen dan atas nitrogen pun ada substituent. So sekarang ni, awak tengok ada lagi tak important functional group present in this compound apart from nitrogen?
No, Miss.
No, maksudnya kita akan dapat amine lah nama dia. Okay, sekarang ni in IUPAC, you need to look for the longest parent chain. Longest parent chain that hold the nitrogen. Okay, ingat balik. And kalau amine ni dia boleh occupy NH3. So boleh ada 3 keliling dia ataupun dia boleh ada 2 sahaja, ada alkyl group, 1 alkyl group. So awak tengok, kalau dia duduk kat tengah macam ni, what is the longest carbon chain yang kita boleh ambil dalam compound ni? Kita nampak nitrogen, okay, nitrogen kita kat sini, yeah. So 3 sebab apa? Sebab awak tahu N ni kita kan ada 3, 1, 2, 3. Awak nampak sekarang, 1 you got CH, CH3 tu. Yang ni kita ada hydrogen dan lagi satu kita ada C, right? So cukuplah 3 dia. So ada 3, maksudnya 3 bond tu. So 3 tu yang dekat mana? Yang atas ke, yang kiri ke, yang bawah?
Atas.
Atas.
Yang atas ke? You sure? Yang ni?
Yang dekat sebelah dia tu, I mean.
Sebelah dia. Sebab kalau yang ni, awak ada basically sama kan? Betul tak sama?
Miss, sama.
Dia sama je. Okay, tak apa. Kalau macam tu kita ambil yang bawah lah senang. Sebab kita nampak ni. 1, 2. Sebab dia dah lukiskan untuk kita. Dia sama je sebenarnya. So kalau yang ni, the longest carbon chain, nama dia apa? Kalau 3,
Propanamine.
Propanamine.
Now your nitrogen is at carbon number
2.
2. So the parent should be 2
propanamine.
Good. Okay. 2 propanamine is only this part. What about the alkyl group attached to this nitrogen?
Isopropyl.
Okay, the isopropyl group is located at nitrogen or carbon?
Nitrogen.
Nitrogen. So kalau kita ada substituents on the nitrogen in aliphatic amine, how are we going to indicate the locations?
N.
And so the name should be?
N isopropyl 2 propanamine.
Yes, N isopropyl 2 propanamine. Okay. Boleh ikut lagi? Boleh clear Macam mana nak keluarkan nama ni? Kalau tak sure, keluarkan dulu yang macam merah saya buat ni. Bagi nampak dulu, takut tersilap. Okay, untuk B pula. When you have C6H5 means this is
Aromatic.
aromatic compound consists of 6 carbons, so your benzene ring. Okay, and then attached to it we have C. So this is our C containing H. On our carbon here we have CH3. Okay, kita ada satu CH3 sini sebab dia buat dalam parenthesis. And then kita sambung, we have CH2, and then kita tarik lagi satu, we have NH2. So NH2, kita buat macam ni lah. Ni bagi nampak NH2. Okay, but before we go about this question, sekejap yang ni dia punya classes of amine dia apa? Primary, secondary, or tertiary? Secondary This one is secondary. Okay. Yang ni pula, kalau kita ada nitrogen directly attached to it, only one alkyl group.
Primary.
Primary. So, bila primary, apa nama compound ni? So, awak tengok sekarang, awak kena tengok parent, bukan pada karbon yang banyak saja. Mesti hold the nitrogen, the amine. So, kita akan ambil this part. Okay, how many carbons that makes up this amine?
3.
Three.
Three.
Then the nitrogen is located at which carbon? Number
1.
1.
Number
1,
1.
2 and 3. So nama dia akan jadi apa? Dia punya parent dengan family?
2, 9, 1 propanamine.
Okay, so dia punya ni adalah 2 phenyl. Dekat carbon number 2 you have phenyl. And then kita punya parent adalah tadi 2 propanamine sebab at carbon number 2. Now kat carbon number 1 nama dia jadi 1 propanamine sebab dia duduk ujung sekali. Okay. Right. And what about this one? See, we have ammonia, we have amino group and also halogen. So between these two, who's got the highest priority antara dua ni? Amino or halogen?
Amino.
Amino. So the numbering should start from here. Jadi kalau kita ada aromatic amine, means nama dia akan jadi aniline. And then what about this chloro? They are located at carbon number
2.
2. So the name should be
2-chloroaniline.
2-chloroaniline. Kalau kita nak guna prefix 1, 2 positions, kita guna apa?
Ortho.
Okay, ortho-chloroaniline. What is the class of amine for this aniline? Look at the nitrogen here. Attached to it, how many alkyl group?
1.
1.
So, dia adalah primary. Tapi dia primary aromatic. Okay, and lastly, we have this C6H5. Again, we have benzene. So, this benzene ring attached to it is nitrogen. Okay, let's say we have here the nitrogen. Okay, on the nitrogen, one bond we got CH2, CH3. Another one we have CH2, CH2, CH3. Okay, so now you have to choose whether the parent should be aromatic or aliphatic. Okay, because all 3 bonds attached to this nitrogen belongs to carbon. Okay, jadi awak nak pilih mana? Siapa paling banyak carbon?
The benzene.
The benzene ring. So kalau you want to make this as your parent, the name should be siapa parent and substitute dia punya family? Aniline kan?
Yes, miss.
Okay, and then located on your nitrogen, we have two alkyl groups. So how do we name this compound?
N ethyl
Mm-mm.
and propyl.
N-ethyl
Okay,
propyl.
N ethyl sebab E dulu, and then N propyl,
Propyl.
yes, aniline. Macam tu je. N ethyl and propyl aniline. Okay, habislah. Boleh ni? Amy? Okay, I'll proceed ya. Okay,
Okay,
sekarang
Miss.
ya, untuk soalan face to face pula, you're given a name of compound, then you need to draw the structural formula. Okay, the first one, we have 2-propanamine. So when you have 2-propanamine, the longest carbon chain should be
3.
3. So we have 1, 2, and 3. And then the 2 belongs to the amine. Means at carbon number 2, you're gonna have
NH2.
NH2. Good. So this NH2 means dia adalah um, classes of amine apa? Kalau awak ada NH2.
Secondary.
Is it secondary? Look at the nitrogen. How many
Primary.
alkyl group attached to it?
1.
Only one. So this is going to be
Primary.
Okay, this is primary. Okay, and then we have B3-aminobenzoic acid. So bila ada benzoic acid, who's going to be the family? Adakah amine?
Carboxylic.
Yeah, carboxylic acid. So we have COOH. This should be carbon number 1. And then the amino means the amine will be the substituents at carbon number 3. So carbon number 3, you have amine in here, NH2. Kalau amino, NH2 sahaja. Dia takkan ada yang alkyl group. Okay, and then for this one, dia primary, secondary or tertiary kalau awak tengok dia punya amine?
Primary.
Primary, tapi sebab dia bukannya the family, jadi kita tak boleh nak classify lah sebab dia belongs to COOH. Okay, tapi kalau dia buat reactions bolehlah dekat sini. Ada reactions yang akan berlaku. Then dekat C pula, we have N-butyl, N-ethyl, aniline. So who's gonna be your parent and family? Kalau dari nama tu. From the name, aniline means we have aromatic amine, right?
Yes.
Okay, kita ada aromatic amine. And then directly attached to it, we have nitrogen. Okay, on the nitrogen, we have two substituents. One is butyl, one is ethyl. So butyl, how many carbons?
4.
4. 1, 2, 3, 4. Make sure cukup 1, 2, 3, 4. Okay. Kalau ethyl pula berapa carbon?
2.
2. So kita ada 1, 2. Make sure awak buat betul-betul. 1, 2. Saya takut nanti awak kira daripada nitrogen. Jangan kira pada nitrogen. Setiap bucu tu adalah carbon. Allah. Okay, and then we have for D, kita ada N-dimethyl 1-butanamine. So N-dimethyl 1-butanamine, the family should be 1-butanamine, how many carbons?
4.
4. 1, 2, 3, 4. At carbon number 1, we have NH2. Okay, tapi kalau kat sini dia awak tengok, awak ada NN. Maksudnya kita ada NH2 ke?
No.
No. Okay. So dekat N ni sepatutnya kita ada substituent of methyl. So tariklah methyl berapa carbon?
1.
1, 1. So kalau kita tengok, betul tak? N-dimethyl 1-butanamine. So carbon number 1 dekat sini. 1, 2, 3, 4. And lastly, you have trimethylamine. This is IUPAC or common name, the trimethylamine.
Common name.
Common name. Okay, so kalau amine sure kita ada nitrogen. Okay, the nitrogen got 3 bonds and you have methyl, 3 of them. CH3, CH3, CH3. Okay, so biasakan bila lukis amine tu letak sekali dia punya lone pair. Okay, ya. Okay, boleh?
Boleh, Miss.
Boleh, Miss.
So tak ada apa nak tanya, kita proceed. Untuk non-face-to-face questions pula, kita akan masuk the properties, the physical properties. Okay, you learned yesterday we have boiling point regarding primary, secondary and tertiary amine, and then when we compare to other compound as well as carboxylic acid and alcohol. Okay, kita tahu dia kedudukan nitrogen because of the electronegativity. Okay, and then we have solubility as well. They are soluble in both water and also organic solvent. Kalau dalam water, hydrogen bonds. Kalau dalam organic solvent, we have formations of van der Waals forces. Okay, and then the last one is basicity. Okay, so basicity is just the opposite to acidity. Look for the ability for the lone pair to donate its lone pair untuk ambil hydrogen. Okay, for the first question, explain why the boiling point of N,N-dimethyl-methanamine is 4 degrees Celsius while 1-propanamine is 49 degrees Celsius. So, how are you going to answer this question? Boleh tak terus kita jawab? Ke Wan nak keluarkan structure dia dulu?
Keluarkan structure dulu.
Okay, keluarkan structure dulu. Sebab dari structure kita baru boleh nampak dia punya classes of amine kan?
Yes, Miss.
Okay, so N,N-dimethyl-methanamine means your amine got parent chain of how many carbons? Kalau dari nama ni?
One.
Only one. So kita pun start, kita buat CH2 and H2 ni kita start lah. But then dia ada N dan juga N. Means dekat dia punya nitrogen, dia takkan ada hydrogen. Dia akan ada alkyl group. So you have C, ini. It should be CH3. Yang ni pun CH3, CH3. Okay, right. So this is your dimethyl-methanamine. So dimethyl-methanamine, what is the class of amine?
Tertiary.
Tertiary. Okay, kita tahu this is tertiary amine. And then 1-propanamine also got 3 carbons, tapi dia punya dia punya classes of amine apa? Tadi tertiary.
Primary.
Yes, primary because you have just straight chain CH3, CH2, CH2 and H2. Okay, so this is primary amine. Okay, in terms of boiling point, you are going to look at the N,N-dimethyl-methanamine to form intermolecular forces between themselves. Okay, intermolecular forces apa yang ada dalam N,N-dimethyl-methanamine out of the 3?
Van der Waals.
Only van der Waals forces.
Yes.
Okay, it's, you know in van der Waals forces, you might have London forces and dipole-dipole kan?
Yes, Miss.
Okay, dalam ni ada tak dipole-dipole?
Ada.
Ada.
So dalam ni ada dipole-dipole dan juga obviously London forces lah kan?
Yes, Miss.
Okay, kalau yang primary pula, because we have this hydrogen directly attached to nitrogen and if they facing each other means the neighboring molecule akan ada lone pair, means dia boleh buat
Hydrogen bond.
yes, hydrogen bond as well as dipole-dipole lah dan juga London forces. Okay, how are you going to start answering this question? Dia bagi tahu tak boiling point siapa lagi tinggi pada siapa? As in, dia ada bagi tahu tak yang cakap nombor kita sekarang ni bayangkan 4 degree dengan 49 degree, kita tak tahu siapa lagi besar. Dalam segmen ni dia ada cakap tak 4 degree is higher than 49 degree ataupun 49 degree is higher than 4 degree. Ada tak dia mention?
Tak ada.
Tak ada. Jadi kalau awak jawab, maksudnya awak bagi 1 point. Awak kena cakap yang apa? Awak kata siapa yang lagi higher, 1-propanamin ke N-dimethyl?
1-propanamin.
Yes, so awak boleh cakap lah juga sebab dia tak mention, dia hanya bagi statement. It's your job to emphasize which one got higher due to intermolecular forces present. Okay?
Okay.
So kita boleh start jawab. Awak boleh cakap yang 1-propanamin has higher boiling point than N-dimethyl methanamine due to
Hydrogen bond.
the presence of hydrogen bond in primary amine, while tertiary amine, ni macam saya rasa macam ni, kejap. Awak rearrange dia. 1-propanamin is a primary amine, has higher boiling point than N-dimethyl methanamine, which is tertiary amine lah. Okay, maksudnya awak naikkan ke atas. Bagi nampak sikit. Tertiary amine. Ni saya buat ke bawah, saya terlupa kat atas tadi. Tertiary amine can only form weak ke strong? Weak. Van der Waals forces. Boleh masuk siap-siap lah atas tu. So awak cakap hydrogen bond is stronger than Van der Waals forces. Therefore, banyak tak energi yang diperlukan?
Banyak.
Yes, more energy needed to overcome the forces, the intermolecular forces between them. Okay, tu je. Okay, kalau macam ni soalan ni markah dalam 3 maksimum sebab awak mention yang dia lagi tinggi kat sini. And then you also mentioned about in primary amine you have hydrogen bond, dan juga tertiary amine you have van der Waals forces, and then you emphasize that hydrogen bond is stronger than van der Waals forces. So at most 3 marks. Okay, and then for the second one, solubility. Okay, as you know already, solubility, the amine is soluble in both water and also organic solvent. But what matters is how many hydrogen bonds can be formed. Okay, so compare the solubility of trimethylamine. So trimethylamine kita ada N and then we have CH3. CH3. This is primary, secondary or tertiary? Tertiary amine. Okay, sekarang dia cakap solubility in water. Sekarang ni kita nak tengok bila dia facing water. Okay, when facing water with this lone pair, okay, can this tertiary amine form hydrogen bond in order to be dissolved in water?
No.
Boleh tak? Tak boleh. Sekarang dia facing water, bukannya the trimethylamine. Dia cakap
Boleh.
Okay, sebab dia ada hydrogen directly attached to either F, O ataupun N kan?
Yes.
Okay, and then facing this hydrogen, we have the lone pair, right? So can they form hydrogen bond?
Can.
Can. Okay, lagi satu dia cakap
Yes.
methyl amine. So kalau methyl amine, you have CH3 and H2, right? Okay, so bila awak facing water, okay, bila facing water, kiranya water ni bukan satu ni je lah, dari atas pun ada juga. Okay, water. Okay, let's say here you use this NH kat sini. Lepas tu kalau dia buat hydrogen bond, dia boleh buat dekat sini contohnya. Lepas tu kalau kita nak guna kita nak guna OH yang kat sini pula, kita nak guna NH dekat sini, dia boleh buat hydrogen bond dengan lone pair ni. Maksudnya dari amine tu sendiri dah boleh berapa dah? 2 kat sini. Nitrogen ni pun boleh juga kan? Kalau dia facing water kat sini, right? Boleh
Yes.
tak? Boleh. So lagi banyak lah. Kalau yang tadi dia mesti datang pada water. Dia hanya guna lone pair, hanya satu tempat ni sahaja. Yang tu sampai 3 kan? So apa yang awak boleh cakap dekat sini? Both got greater solubility.
Methyl amine.
Methyl.
So bagi tahu methyl amine ni class of amine dia apa?
Primary.
Yes.
Primary.
Methyl amine is a primary amine. Has higher ataupun cakap more solubility than siapa? Higher solubility in water, bagi tahu dalam solvent apa? In water than trimethylamine. Buat dalam kurungan tertiary amine. Because it can form
More hydrogen bond.
because it can form more hydrogen bond. Lukisan dekat atas tu, awak tak perlu nak lukis pun tak apa. Kalau tak lukis tak payah, tak ada markah pun. Kita lukis just nak bagi nampak. Okay. Right. Okay, habis dah untuk these two physical properties. Dan ni pun masih boiling point. Okay, so you're given different compound. So the first compound here, you have, what is the name of this compound? 1, 2,
Propan.
3. Nama dia?
Propanol.
Yes, 1 propanol. The second one, we have 4 carbons. 1, 2, 3, 4. Means dia adalah do you have any
Butane.
functional group? Butane, great. This is simply alkane, got no functional group and it's 3-chained. And then here, when we have nitrogen means kita ada amine, and then look at the nitrogen attached to it is H2, means this is amine apa? Primary, secondary or tertiary?
Primary.
Okay, primary. Tapi sekarang ni, what is the name of this amine?
Primary.
Okay, primary, betul. This is carbon number 1. Okay, at carbon number 1 kita ada CH3. Dia boleh jadi carbon number 2. One of them akan jadi apa? Branch kan?
Branch.
Okay, so nama dia apa?
Branching.
1. Dia takkan jadi branch lah. Dia jadi branch. Dia tak jadi branch. Dia jadi,
Isotope.
dia punya longest carbon chain dia adalah 3 kan? Betul tak? Dia macam ni. Dia C, kita ada H, kita ada CH3 kan? Ini NH2, betul tak?
Betul, Miss.
So longest carbon chain kita 1, 2, 3 kan?
Betul Miss.
Okay, so nama dia? When NH2 is located at carbon number 2,
2 isopropyl.
isopropyl?
2 propylamine. Sorry.
Yes, 2-propanamine. 2-propanamine. Okay, the last one. We got on also three carbon, maksudnya propanamine juga. Tapi kat sini kita ada longest carbon chain of 3 dan NH2 tu dekat hujung kan?
Yes.
So nama dia 1-propanamine.
Propanamine.
So if we need to kita kena susun dia, susun ikut urutan, who's got the highest bonding point? Ascending order, you Kana?
Miss nak tanya, like
Yes.
if it in bracket bukan branching ke? No.
Yang mana? Yang 2-propanamine tu eh?
Ya betul.
Betul, dia branching tapi sekarang dia condense. Bila dia condense, benda yang sama. Kalau kita tengok dia punya bonding tu cukup, walaupun nampak dalam tu branching tapi sebenarnya tak branching pun. Dia nak bagi tahu yang dia compress sekali macam tu.
Oh okay Miss. Faham Miss.
So macam tu lah. Dia kadang-kadang ada juga orang buat SH tu tapi banyak kan, dia buat 6. Maksudnya benda tu bersusun-susun. Dia boleh letak CH3 ni sebab dua-dua CH3 ni attach to this carbon.
Okay Miss.
Okay.
Faham Miss.
Right. So the highest bonding point goes to siapa paling tinggi? 1-propanol, butane, 2-propanamine or 1-propanamine? Boiling point ni tengok siapa boleh buat hydrogen bond, tengok electronegativity dia. Siapa paling tinggi?
1 propanol.
1-propanol, okay, kita katalah kita guna A. Awak boleh kalau nak guna unknown tapi kena define dulu atas kertas jawapan. Jangan
Okay.
define atas kertas soalan lepas tu tak salin balik. Nanti tiba-tiba ABC orang tak tahu. Buat dulu macam ni, lepas tu ABC.
1-propanamine.
Okay, lepas tu 1-propanamine followed by
2 propanamine.
2-propanamine and lastly butane, right?
Butane.
Okay, so it is better for you to first susun siap-siap baru kita masukkan. Maksudnya letak huruf tu ikut susunan dah. So kita ada yang paling tinggi is A, followed by B, followed by C, followed by D. So this is our ascending order of boiling point. And then you need to explain your answer. Okay, so between A, B and C, we know all of them can form hydrogen bond, right?
Yes.
Yeah,
Yes.
so awak boleh cakap yang all compounds silap. Compounds A, B and C can form hydrogen bond, but compound A paling tinggi kan?
Yes Miss.
Has the highest PP due to, kenapa kita pilih 1-propanol? Kenapa? Electronegativity of
Oxygen.
oxygen is higher than N.
Nitrogen.
Oxygen.
Higher than N, hence more polar. So cukuplah kita dah bagi tahu yang dia highest. Okay, jangan guna higher, highest sebab dia paling tinggi. Lepas tu kita masih cakap antara B and C pula. Compound B has higher boiling point than siapa?
Compound C.
And C due to straight chain kan?
Yes.
Straight chain compound. Bila kita kata straight chain ke yang lagi satu tu branching ke, kita nak cakap tentang the surface area.
Surface area.
Yeah. Due to straight chain compound provide bigger surface area kan?
Betul.
The surface area sebab dua-dua adalah primary area, hence more hydrogen bond can be formed. Okay, last point. Siapa paling rendah?
Compound D.
Compound D. So compound D kenapa the lowest?
It can't form hydrogen bond.
Yes, has the lowest BP because it can only form,
van der Waals forces.
yes, weak van der Waals forces between molecules. Macam itulah jawab dia. Okay, sebab kita dah cakap dia weak, saya tak payahlah cakap molecule lagi kuat daripada van der Waals forces. Okay. Right, habis dah untuk yang ni. So kalau macam ni, 4 markah kadang-kadang untuk trend, lepas tu explanation, sentuh semua. Okay, habis untuk face to face, oh belum lagi. Ni pun sama boiling point ascending juga. We now have propanol, so alcohol. Alcohol kita tahu boleh buat hydrogen bond, right? This is hydrogen bond and straight chain. Keluarkan point dia. Saya tak cerita dia lah, saya just keluarkan ni. Straight chain. Ethanoic acid kita ada hydrogen bond, tapi hydrogen bond biasa ke ada special feature? Ada dimers kan, stable dimers, right?
Yes.
Stable dimers. Lagi dia pun kiranya straight chain lah, tak payah tulis. And then kita ada chloroethane. The chloroethane, can we form hydrogen bond between chloroethane?
No.
No, chloroethane kita ada C dengan Cl, means at most dia boleh buat
Van der Waals forces.
van der Waals iaitu dipole-dipole kan.
Yes, miss.
Okay, lepas tu 1-propanamin kita tahu yang dia boleh buat hydrogen bond. And dia pun straight chain juga. Okay, jadi siapa yang akan jadi paling tinggi?
1-propanol.
Is it 1-propanol? Bukan ethanoic acid?
Ethanoic acid.
Yeah,
Ethanoic acid.
ethanoic acid got the highest, followed by
1-propanol.
Propanol.
1-propanol, then
1-propanamine.
1-propanamin, and lastly chloroethane.
Chloroethane.
So A is greater than B, is greater than C, greater than D. So nanti kalau cerita nak start dengan apa dulu? Compound A lah.
A.
Compound A bagi tahu highest sebab ada stable dimers, right?
Yes, miss.
Lepas tu bagi tahu juga yang they are arranged closely packed. So cerita siap-siap dekat sini yang hydrogen bond dia lagi kuat. And then second point kita akan cakap nak compare siapa dengan siapa?
B and C.
Yes, compound B and C both got straight chain, so tak payah cakap. Just cakap yang this one got oxygen,
Electronegativity.
this one, yeah, this one got nitrogen, so electronegativity sama macam tadi. Saya tak explain lebih lah. And then lastly chloroethane. Chloroethane ni still polar molecule, tapi dia hanya boleh buat van der Waals forces kan.
Yes, miss.
Okay. So sama jugalah kalau dia punya marking pun 4 marks macam tadi juga. Sama tahu awak tengok balik je ni nanti. Okay, can I proceed?
Can, miss.
Right. Still in physical properties, but now we have in terms of basicity. Okay, basicity ni baru first time nak buat. So as for basicity, okay, basicity kita tahu kita nak the nitrogen tu banyak elektron dekat dia. Means siapa yang attached to the nitrogen kena provide electrons. Okay, keluarkan dulu. Ammonia, you got nitrogen, keliling dia ada
3 hydrogen.
3 hydrogen only. Okay, so hydrogen ni just bawa 1 elektron. And then methanamine still ada 3 bonds, and one of them we have
Alkyl group.
yeah, CH3, means lagi 2 adalah hydrogen. Okay, aniline pula we have
Benzene.
benzene ring directly attached to it. Kita ada
NH2.
NH2. Okay, and then we have this another aniline. Okay, another aniline. Kita ada NH2 juga. 1, 2, 3. And dekat P adalah para, maksudnya 1, 4, right?
Yes.
You have NO2. Okay, so kalau ikutkan NO2 tu bentuk dia macam ni lah. O2. Okay. So kat sini mungkin dia negatif. Ini adalah positif. Tapi kita tahu NO2 je. So kita tahulah dia banyak elektron kan dekat NO2 tu. So nak senang lagi nampak NO2. So sekarang ni kita fokus kita dekat siapa? Dekat this nitrogen. Okay, nitrogen, the lone pair on the nitrogen, whether they have high density of electrons or not. Kalau lagi banyak elektron maksudnya lagi basic, lagi kuat base tu sebab dia nak pergi donate the lone pair. Okay, sekarang ni, look in your ammonia. Your ammonia got only hydrogens and they are going to provide electrons towards this nitrogen. Will they gives you greater effect in terms of electron density than the methanamine?
No.
No, sebab dekat sini satu elektron. Tapi kalau methanamine, kita tahu dia adalah elektron donating or withdrawing?
Electron donating.
Donating. Okay, dia akan bagi elektron. Ni pun akan bagi tapi sikit lah. Okay, satu. Yang ni pula contoh daripada carbon dah berapa, H dah berapa. So bagi. Ni pun bagi juga. So yang ni lagi tinggi lah daripada dua ni. So dia ada the presence of EDG. Bila nak cerita, awak kena compare yang compound yang lebih kurang sama. Okay, kalau yang aniline kita boleh compare dengan para nitroaniline. Both got lone pair, maksudnya lone pair pula. Both got benzene ring. Kalau ada benzene ring kita akan discuss about effect apa? Group ke kita nak cakap pasal resonance?
Resonance.
Okay, so kalau dua-dua ada resonance, basically tak perlulah nak explain when comparing these two, tak perlulah nak emphasize tentang resonance, tapi kita bolehlah guna point resonance tu bila nak compare dengan yang lagi dua tadi sebab kita nak tunjuk dia trend kan. So resonance. And then on your aniline, we got only hydrogen attached to all this carbon, right? Okay, tapi kalau yang kat sini pula, awak ada satu daripada hydrogen, kita dah replace dengan NO2 group. NO2 group, kalau tadi CH3 is alkyl group, electron donating. Kalau NO2 ni, dia group apa? Dia kaya dengan elektron, jadi dia akan tarik elektron ke arah dia. So nama group ni?
Electron withdrawing.
Yes, electron withdrawing group. So can I know, by having resonance effect, the basicity will increase or decrease?
Decrease.
Decrease. By having electron withdrawing group, will the basicity increase or decrease?
Decrease.
Okay, decrease kan? Okay, so kalau yang sini pula, kalau ada electron donating, dia akan increasekan the basicity. Jadi, who's got the highest boiling point? So kita tunjuk kat dia. A, B, C or D. A siapa? Yang paling tinggi?
Methanamine.
Methanamine. So this is going to be your A followed by
Ammonia.
ammonia, betul? And then
Aniline.
aniline dulu. Okay, aniline. Last one gonna be para-nitroaniline kan?
Yes, miss.
Okay, so bila kita susun, kita ada dia sebab dia nak ascending. Okay, ascending A followed by B, followed by C, followed by D. Okay, bila kita nak explain kan, awak boleh cakap yang A dengan B lagi tinggi daripada C dengan D sebab apa? Sebab dia orang tak ada resonance effect, betul tak?
Betul.
Ya, so awak boleh cakap lah yang compound A and B has higher basicity than C and D because they have no resonance effect. So bagi tahu sikit apa yang resonance effect tu akan buat. Resonance effect will apa? Will decrease the basicity of compound dengan cara apa? Apa yang kita buat bila resonance? Where delocalizations of electron kan?
Betul Miss.
Betul.
Delocalizations of electrons in the benzene ring. Okay, kena bagi tahu. Bukan kita tak nak cerita dia, cuma nanti bila compare yang aniline tak perlu cerita dah lah in the benzene ring. Okay, so kita dah cerita tapi belum cakap siapa lagi tinggi antara A dengan B. Just bagi tahu in general. Lepas tu kita cakap compound A has higher or lower?
Saya.
Higher basicity than B due to the presence of
Electron donating group.
yes, presence of electron donating group. Apa yang electron donating group tu akan buat? Apa electron donating group buat tadi? Dia bagi siapa? Dia akan buat apa dekat electron density of N?
Increase the electron density.
Yes, will increase the density of electron on nitrogen. Kita nak jawab dari segi Lewis, making it more basic or less basic?
More.
Ya, making it more basic. Dah cukup lah sebab kita dah cerita kan. Kalau awak pilih untuk cakap dari segi Lewis, awak katalah yang dia lagi basic. Kalau awak nak cerita dari segi conjugate, awak kata yang dia stable. Jangan campur dua-dua. Dia kena salah satu. Okay.
Okay Miss.
Alright. Sama lah kalau macam acid pun, saya itu ajar dua-dua dari segi Lewis dengan conjugate. Kalau awak nak cerita pasal stable, awak kena cerita lepas reaction dah berlaku. Kalau awak nak cakap pasal electron density, yang dia ni more acidic ke tak, awak kena cakap yang sebelum tu. Okay, lepas tu kita nak cakap antara dua ni pula sebab ada electron withdrawing. So bagi tahulah yang compound D lagi rendah kan. Compound D has lower basicity than siapa? Then C, kenapa dia lagi rendah? Dia ada apa kat situ?
Electron withdrawing group.
Yes, electron withdrawing group buat apa?
Withdraw the lone pair.
Will decrease lah, decrease electron density lah. Dia tak adalah withdraw the whole thing. Decrease the density of electrons on nitrogen, hence making it less basic. Macam itulah, okay? Right, habislah untuk explanation ni. So ni pun 4 markah. 4 markah dekat mana? 1, 2, 3, 4. Okay, jangan ulang ayat point yang sama. Make sure awak dah sentuh semua dah. Right. Okay, next one kita tengok reactions pula sikit. Identify A until E in the following reactions. Okay, here you have haloalkane with how many carbons? 1, 2, right?
Yes Miss.
Okay, on your product, you have nitrogen. Okay, itu satu pasal. Your nitrogen and your number of carbon bertambah juga, right?
Yes.
Okay, so awak ada nitrogen, this is a hint. So keluarkan dulu nitrogen, 1, 2, 3. One of them got hydrogen, one of them got CH2, CH3. Yang ni pun CH2, CH3. Okay, maksudnya yang kita ada dari reaktan asal hanyalah this part, kan?
Betul.
Okay, means your compound A should be apa? Yang selebihnya, right?
Yes Miss.
Ni, tapi kalau kita ambil yang ni je, nitrogen kurang satu bond. Jadi siapa yang kita kena tambah dekat nitrogen tu?
Hydrogen.
Hydrogen. So your A should be NCH2CH3. Kita ada hydrogen and hydrogen. This is class of amine apa ni? Primary, secondary or tertiary?
Primary.
Primary. What is the name of this compound? According to IUPAC, apa nama dia? Ni paling panjang.
Ethylamine.
Ethylamine. Good. What is the type of reactions involved? Bila kita react these two. Ni reactions dekat chapter berapa ni? Chapter 9. Kalau kita tengok haloalkane dia kat chapter 7. Kan?
Yes, miss.
Kalau kita tengok yang kita react ni dekat chapter 11. Awak rasa dia comes from chapter 11 or 7?
7.
Yes, this comes from chapter 7. Kalau ikut 11 tak ada reactions ni. Tapi sebab kita dah jumpa yang tu, bolehlah juga dia. Okay, next. B. We have this compound of apa? Can I know when we have CN means this compound is called?
Nitrile compound.
Yes, this is nitrile compound. Good. Nitrile compound, kita boleh form dia dari siapa? Ke memang ada dah CN? Ke kita boleh form dia sebelum nak dapat CN tu? Awak kena lalui chapter berapa?
6.
7.
7.
7. CN. Ingat balik. Strong nucleophile.
Strong
NaCN. Kiranya. Kan? Betul tak?
Betul, miss.
CN tu dia tak ada asalnya, dia memang mesti datang daripada haloalkane dulu. Okay. So now this nitrile compound undergo reactions of apa ni? Bila kita ada lithium aluminium hydride and H3O+.
Reduction.
Reductions, good. Kalau reductions kita tahu from multiple bond before this CO. Now here we have CN. Kita nak reducekan dia punya multiple bond. So maybe nak jadikan apa? Nak jadikan single bond ke ataupun double bond lah. Okay, so kalau kita ada nitrile compound undergo reductions, kita akan dapat apa? Kalau carboxylic acid undergo reductions dapat alkohol kan?
Yes, miss.
Kalau nitrile compound dapat alkohol juga ke?
Amine.
Dapat amine. Tapi dapat amine class, different classes or only one classes?
One
Primary.
class.
One only.
Primary.
So hanyalah primary. So kita ada hilang carbon tak dalam reductions of nitrile compound? Ada tak kita kurang carbon? Ke sama number of carbon dia?
No. Same.
Same. Okay.
Same.
So kita kekalkan balik structure kita. You have CH3 surrounds this carbon. CH3. And you got another CH2. And you have CN. On the CN ni lah kita akan jadi the single bond. N. Dekat C ada 2 H. Dekat N ada juga 2 H. So this is your primary amine. What is the name of your amine here? The longest carbon chain of? 4. 4. The numbering starts from the right or from the left?
From right.
From right. Means the name
Right.
should be? Nama dia apa?
3,3-dimethyl.
3,3-dimethyl.
Butanamine.
Butanamine.
Awak primary, secondary, tertiary?
1 butanamine.
Yes, dimethyl 1 butanamine. Okay, good. Butanamine. Okay. C pula. You have this CH3. Here we have this one CONH2. What is the compound given here? Give me the general idea about this compound. You have CONH2. Is this?
Amide.
Yeah, amide. So this is going to be amide. Okay. So amide undergo reactions to become amine. Okay, itu satu hint. you also need to check the number of carbon, okay, because in order to prepare amine, kita ada semua reductions, okay, but then what matters is whether the number of carbon still the same or it is being reduced. Okay, kena hati-hati sebab one of the reactions involve degradations of carbon. Okay, so kita keluarkan dulu structure asal dia. Kita ada one, this one is C, lepas tu kita ada 1, 2, CH3, CH3, this one is hydrogen, C, double bond O, NH2, 2 become okay, C, CH3, CH3, CH3. Saya rasa dia tertinggal dia macam tak cukup kan? Kat sini dia ada dia tertinggal H ni Wak. Sini ada CH2 and H2. So look for the number of carbon. Are they the same or different?
Same.
Same. Kalau same maksudnya kita buat reductions guna apa?
LiAlH4.
Okay, the lithium aluminium hydride, right?
Yes, miss.
Okay, lithium aluminium hydride, but usually we use H3O+. Kalau ada amide, kita kena guna
Water.
water only. Jangan guna H3O+, okay?
Okay, miss.
Okay, this is your C. Kita habiskan soalan ni je lah. Sekejap, saya tak ada ruang. Bolehlah ni kita buat kat sini. Kalau D pula, this is a reactions juga because you are going to form these aromatic amine. Okay, aromatic amine. To form aromatic amine, you got only one reactions of compound apa yang perlu kita guna?
Nitro compound.
Nitro compound. So now you formed both carbon got NH2, means nitro compound awak pun kena ada
NO2.
yes, ada dua lah kan dia punya NO2 tu, atas dan bawah. So sini kita ada NO2, NO2. Okay, apa lagi yang kita boleh guna selain SN dengan HCl? Kita boleh guna
Fe dengan H+.
yes, Fe, HCl pun boleh. HCl ni basically H plus awak tu lah. Satu lagi zinc kan?
Yes, miss.
Zinc, H plus pun boleh. Okay. Lastly, you have this compound of amide, again amide. Okay. So dekat sini, awak ada amide sama reactions tadi. The number of carbon 1, 2, 3. Sini pula tinggal 2. Okay, what happened to the number of carbon?
Reduce.
Berkurang. Okay, tengok dia punya dia punya apa kita panggil tu? Dia punya side product contain Br. Okay, so by having this Br maksudnya your reagents pun kena ada this Br species. Okay, can I know what is your reagent for E?
Br2, NaOH,
Br2,
and H2O.
oh, H minus together with H2O, right?
Yes, miss.
Yes.
What is the name of these reactions?
Hoffman's degradation.
Okay, Hoffman's degradations is used to buang carbon tapi dia buang carbon apa? Dia buang carbon double bond O, the whole thing here, right? For face-to-face questions, third hour, the first questions wants you to outline the synthesis of the following. Bila sebut synthesis, bear in mind kita kena involve certain reactions from other compound as well, okay, in order for you to get the product. Okay, now for 1A, we have 2-methyl 1-propanamine from 2-propanol. So kita nak start daripada siapa? Propanamine ke propanol?
Propanol.
Propanol. So kita ada propanol. How do we draw the propanol? The 2-propanol. Longest carbon chain of
3.
3. And then when it comes to 2-ol means the OH at second carbon, OH. So this is your 2-propanol. You want to form 2-methyl 1-propanamine. The number of carbons still the same or different?
Sama.
Sama, 1, 2, 3. Tapi instead of having your functional group at carbon number 2, daripada 2-propanol dia akan jadi at carbon number 1. Okay. So here you have NH2. Okay, lepas tu at carbon number 2, you have methyl. So kat sini kita ada methyl. Alright, so how are we going to do this? From OH to become NH2, can we simply get the answer by using only one reagent?
Cannot.
Cannot. Okay, so kita check dulu apa yang ada dekat initial structure dengan our final structure. Our initial structure got 3 carbon, 1, 2, 3. Okay, lepas tu our structure here kita ada probably this one. 1, 2, 3 maybe. Kan? Sebab kita nak tengok asalnya dari mana dia punya heteroatoms kan? You initially got heteroatoms at carbon number 2. That's why kita try untuk locatekan yang kita nak masuk pun dekat carbon number 2. Betul tak? Kelas?
Yes.
Yes. So kalau ikutkan dekat carbon number 2, yang ni lah kita nak masukkan, right?
Yes, Miss.
Okay, jadi ada tak any reagents that can directly transform this 2-propanol to become 2-methyl 1-propanamine?
Tak ada.
Tak ada. So sekarang ni hint saya dah bagi. Kita nak tukar dekat carbon number 2. Dekat carbon number 2 walaupun kita punya drawing tak sama tapi you can always rearrange them to become the same. Boleh je awak nak letak yang NH2 ni dekat atas asalkan nampak sama. Okay, could you please suggest a reagent that can be substituted with this OH? So recall again the reactions involved in chapter 8. Okay, macam mana? Kita selalu guna compound tu as an intermediate. What kind of intermediate do you think? Bila nak jadi intermediate ni dia kena good living group. Sorry?
Can we use SOCl2?
Yes, boleh. Kita boleh first form the haloalkane, right?
Betul.
Yeah. So by having haloalkane, dia a good living group lah. Sebab itulah kita boleh jadikan dia intermediate. So you simply substitute OH with Cl by using, okay, your friend suggests SOCl2. So SOCl2, do we need other conditions in order for this reagent to be used?
Is pyridine.
Yes, SOCl2 in pyridine. Okay, once you undergo this reaction, ingat kalau daripada hydroxy to become haloalkane, dia bukan semua nucleophile macam dalam haloalkane kita boleh guna. Okay, so kita dah secure the 3 carbon and kita dah tukar dengan Cl. Now from this Cl, you want to form amine. And note here, your amine is not just nitrogen, they also got carbon on it, right? You want to add carbon as well. So what kind of compound that can provide both carbon and nitrogen at the same time before you can finally form your amine? In chapter 7, we have 3 reactions: elimination, nucleophilic substitution, and nucleophilic addition. Okay, dalam case ni kita nak buat yang mana? Adakah kita nak buat double bond? Is it necessary for you to form double bond for this case?
No.
Tak tak ada pun when from double bond you want to form the amine. Okay, so disqualified. What about nucleophilic additions? The nucleophilic additions of Grignard. Do you think that you need to form Grignard reagent here? Can Grignard reagent form amine? Ada tak?
No.
Tak ada. Okay, Grignard reagent pun tak ada buat amine. Grignard reagent hanyalah alkohol, alkane ataupun carboxylic acid. So disqualified. So we are left with nucleophilic substitutions. Awak nak ganti Cl dengan something else. From out of the 7 nucleophile we have learned, 3 of them adalah yang strong nucleophile, 4 of them is weak nucleophile. Is there any reactions that can simply change from Cl to become NH2?
Excess NH3.
Okay, excess NH3. Kalau NH3 kita tak masuk carbon, right?
Yes.
Okay. Cuba suggest yang ada C dengan N.
NaCN.
NaCN, yes, good. Kalau kita provide NaCN, kita akan substitute Cl with
CN.
Cn. Okay, so kita akan ada the same number of carbon still, 1, 2, 3. Tapi dekat sini, since you're going to form this Cn, maksudnya kita ada tak extra carbon yang kita dah masukkan? Ada kan?
Ada.
Ada carbon, ada nitrogen. So, to form amine, out of the 4 reactions, we have 4 reductions reaction. Ada tak yang from nitrile compound? This is what we call nitrile compound when we have cyano group on the compound. Jadi, this nitrile compound to be converted to amine. Boleh tak kita buat reactions dekat sini?
Boleh.
Okay, this is a reductions reactions. But reductions in amine, okay, dia kena tengok you nak reduce siapa. At the moment you have carbon multiple bond nitrogen. Bila ada carbon, can you use the same reducing agent as in the carbon double bond O? Sebelum ni kita belajar in acid, in alcohol, in carbonyl compound, you can undergo a reductions reaction and kita pun dah belajar reducing agent, right?
Yeah.
Okay, so bila kita dah belajar reducing agent, so kita always, sometimes we stick to only certain reducing agent. But I already mentioned to you, when you are going to form amine, even though they undergo reductions, tapi bukan semua reducing agent kita boleh guna. It depends pada siapa yang kita nak reduce kan. Okay. Jadi sekarang ni, we have C triple bond N. Okay, C triple bond N undergo reductions, can they use the same reducing agent as in the one we use for C double bond O untuk reduce?
Cannot.
Kalau C triple bond N boleh. Kalau C triple bond N boleh sebab dia masih menyerupai C double bond O. Tapi kalau amide kita tak boleh guna, tak boleh definitely guna tiga-tiga tu. Ada certain saja. Kalau nitro guna benda lain pula. Boleh? Yang tu. Nak bagi nampak sikit supaya awak tak tertukar. Yang ni saya ada cakap air tu. Okay, boleh?
Boleh. Okay.
Okay. Jadi kalau sebab dia C triple bond N, sebab kita nak reduce pun C juga multiple bond, kita boleh guna antara sodium borohydride, hydrogen gas or lithium aluminium hydride, the same as in C double bond O. So let's say we want to use NaBH4, they must be in, kalau NaBH4 kena dalam methanol. Okay. So nanti dapatlah this amine, primary amine. Reductions of nitrile compound will only gives you primary amine sebab dia dah hujung. Bila dia hujung, dia tak akan ambil alkyl group. Dia hanya tukarkan the triple bond jadi CH2. The triple bond jadi NH2, okay? Boleh kelas?
Boleh, Miss.
Okay. Now kita proceed to B. So B, you want to form amide, you could see we have C double bond O here. CONH ni adalah amide from benzene. Okay, from benzene. So we are going to start from chapter berapa tu? Kalau kita start dengan benzene sahaja?
6.
6. So we have 1, 2, 3, 4, 5, 6. So you start with benzene only to form again benzene. Okay, and then kita ada CONHCH3 means directly attached to it you must have C. Then kita ada double bond O. Then only we have this N. Attached to the N, we got hydrogen together with CH3. This is hydrogen. Okay. Can I know what is the class of amine we have in here? The amide, sorry. Apa class of amide yang kita ada kat sini?
Secondary.
Yeah, secondary. We have 1 in here, 2 in here. Okay, so this is a secondary amide. Okay. You want to start from benzene. Okay, in benzene, we have 2 reactions involved. Bukan reactions lah, type of reactions. First, directly on the benzene. Second is side chain of the benzene. At the moment, you have only benzene, so you are restricted to only electrophilic aromatic substitution. Okay, now you want to form this aromatic amide. Could you please tell me how are you going to start doing these reactions? Adakah kita terus, directly, ya betul lah. Adakah kita terus nak awak apa? Tengok, kita ada apa dulu? The first one. Sebelah benzene tu kita ada apa? Kita ada nitrogen ke kita ada carbon?
Carbon.
Carbon. So the hint here, you must first have carbon, then only you can put in the nitrogen, right?
Yes.
Okay, so first kita nak buat reaction apa dulu? Awak kena aim nak tambah carbon. Nak tambah carbon ke, nak tambah carbon double bond O ke, tapi kena check balik ada tak reactions tu kalau sekalipun awak nak tambah carbon double bond O. Tengok pula sebelah carbon awak, carbon double bond O awak ada apa? Nitrogen kan?
Yes.
Nitrogen. So awak kena check dulu. So kita nak proceed dengan apa ni? Awak rasa kita nak guna reagent apa? Out of the 4 reactions taking place on the benzene itself, are we going to add halogen? Substitute halogen, hydrogen with halogen?
No.
No, okay, tak sesuai. Kalau kita substitute halogen, kita tak dapat carbon, right?
Yes.
Okay. Do we need to substitute nitro?
No.
No, sebab directly attached to our benzene is carbon. Okay, kalau tukar nitro tak dapat carbon. Okay, next. Are we going to do the acylation?
No.
Yes. Okay, ada yang cakap yes, ada yang cakap no. Acylations, you want to substitute, okay, you initially got acid chloride means C double bond O, you have alkyl group together with your halogen of Cl kan?
Yes.
Okay, your apa kita panggil tu? Your electrophile will be formed at this carbon double bond O. Bila electrophile double bond O electrophile dekat carbon, maksudnya nanti dia akan masuk dekat sini, right?
Yes.
Kalau dia masuk dekat carbon double bond O, sebelah carbon double bond O kita ada alkyl group, right?
Yes, miss.
Okay. Sebelah awak punya carbon tadi yang kita tengok dekat awak punya secondary amide, do you have alkyl group attached to your C double bond O?
No.
No. And the alkyl group comprises only carbon and hydrogen. It's very impossible for you to immediately remove the alkyl group from the C double bond O. Okay, jadi it is susah lah kalau awak masukkan acyl group walaupun you have secured your C double bond O in here. Dia tak semestinya akan boleh masuk nitrogen pula. Itu faham? Nak bagi nampak kita kena buat apa je instead of masukkan semua terus. Boleh?
Okay, Miss.
Boleh, Miss.
Okay, so sekarang ni acylations pun tak sesuai. Jadi kita tinggal alkylations. Boleh tak kita buat alkylations dekat sini?
Boleh.
Boleh. So your alkylations here, kita akan react dengan siapa? Nak berapa karbon awak nak? Boleh tak kita react dengan 2 karbon walaupun dia minta 1 karbon?
No.
Okay, sebenarnya boleh Sebenarnya boleh. Sebab apa? Sebab kita bukan cakap one reaction ni dapat produk terus kan?
Yes.
Saya try. Okay, kalau ikutkan awak boleh je react dengan C. Contoh, awak selalu akan ambil yang paling senang lah. CH4, right? Let's say CH4. Tapi kita tak boleh guna ni, sorry. Kita kena guna haloalkane kan? CH3, Cl. Okay, sebab you want to secure the 1 carbon. Okay, if you want to secure the 1 carbon, then that's alright. Boleh je masuk. Tapi awak juga boleh je kalau nak react dengan CH3, CH2, Cl ke. Awak nak buat dengan C. Banyak C pun tak apa. Asalkan ada hidrogen dekat dia kan. CH3. Yang ni pun boleh. Kenapa saya kata boleh? Okay, let's say awak react dengan this compound, right? Instead of awak guna yang lain tu. Kenapa saya kata boleh? Okay, our aim here, you want to remove during the electrophilic substitutions tu, kita akan remove Cl, right?
Yes.
Bila kita remove Cl, maksudnya dia akan masuk dekat part yang biru ni, betul tak? Yang sebelah Cl tu.
Betul.
Okay, so walaupun number of carbon dia lebih, let's say saya ambil yang banyak carbon ni. Bila dia substitute, okay, yang ni tak cukup lagi dia punya ni, awak kena ada the presence of AlCl3 juga, okay? Okay, so bila awak substitute kan awak akan dapat, kejap kecil pula benda ni. Kecil sikit. Okay, bila awak dapat this produk nanti, kita akan masukkan the group yang warna biru, right?
Yes.
Betul tak?
Yes, Miss.
So let's say saya ambil kat sini ada 1, 2, 1, 2, 3, baru 3, satu lagi hydrogen, betul? CH3 kan? Kita masuk tak 3 yang ada tadi?
Masuk.
Betul tak? Okay, masuk dah. Okay, walaupun dia ada banyak carbon dekat sini, kita aim sekarang daripada carbon, kita nak dapatkan carbon double bond O, is it?
Yes.
Yes, Miss.
Okay. Once you have side chain of the benzene, are you going to proceed with the reactions on the benzene or the side chain?
Side chain.
The side chain. Okay, for side chain, we got only 2 reactions involved. It's either you substitute with halogen, undergo free radical substitution. So hydrogen tu kita akan tukar dengan Cl, or you are going to do the oxidations. Since you want to secure C double bond O, which of the 2 reactions are you going to proceed with? Oxidations or free radical substitution?
Oxidation.
Oxidation.
Oxidation, sebab kita nak secure C double bond O, oxidations will give you benzoic acid. In order for you to do the oxidations reactions by using the oxidizing agent of apa? Okay, Manopha. Lagi?
K2Cl2O7.
Dia punya ni, condition. H plus. Dengan okay, tak apa. Boleh juga K2Cr2O7 pun boleh. Okay, untuk undergo these oxidations, you must first have apa on your compound? Do you have the two criteria involved? Do you have the benzene?
Yes.
You have the benzene. Do you have the benzylic H? What is meant by benzylic H?
H attached to carbon. That attached to benzene.
The first one kan? Okay, ada tak hydrogen on the first carbon that attached to benzene?
Yes.
Itulah kita panggil benzylic H. Sebab tu saya cakap walaupun dia nak secure one carbon, you can also get the product from this compound kita form as intermediate sebab dia ada benzene and benzylic H. One and only product gonna be benzoic acid, okay? Boleh?
Boleh, Miss.
Okay. So tak kisahlah awak nak ambil yang mana tapi make sure kena obey lah the requirement. So awak boleh je ambil either or yang saya bagi ni. Tak ada salah panjang mana pun nanti dia dapat produk ni sahaja sebab side produk kita tak tengok. So kita dah secure C double bond. Allahu Akbar. Kita dah secure C double bond O, kita dah secure C. Now kita nak ambil apa pula? This one kan? NHCH3, right?
Yes.
Yes.
So kalau ikutkan this NH dengan CH3 dia adalah amine, kita nak masukkan amine. Ada tak reactions in carboxylic acid that involve formations of amide? Dari carboxylic acid ada tak reactions yang kita dapatkan amide?
Ada.
Ada. So kalau ikutkan nitrogen, kita kena ada 3 benda keliling dia. Okay, now dekat pink tu kita hanya ada hydrogen dan juga CH3. So another bond belongs to siapa? Another bond yang kita nak pecahkan belongs to siapa?
H.
H. Okay, good. Jadi inilah kita punya amine yang kita nak react. What is the class of amine yang kita nak tambah ni? When you have only one alkyl group attached to it.
Primary.
Primary. So you're going to react them with primary amine. Okay, jadi kalau ikutkan, kalau kita nak remove H untuk masuk, awak boleh ke react dengan tertiary amine kalau semua alkyl group? Tak boleh. So mungkin dia boleh react dengan ammonia, primary and secondary amine baru boleh dapat amide. Kalau semua alkyl group susah untuk dia pecahkan the bond between N dengan carbon sebab the difference in terms of electronegativity is just 2 groups away. One group away. Group 15 dengan group 14. Very slightly difference in terms of the electronegativity. So dia tak boleh nak pecah lah, susah sikit. Okay, clear?
Okay, Miss.
Alright, so now we'll proceed to the next question. Show the two steps reactions for the conversions of 1-methyl cyclohexene to 2-methyl cyclohexanamine. Okay, so kita keluarkan dulu, dia kata ada 2 steps. So from 1-methyl cyclohexene, cyclic structure or open chain structure?
Cyclic structure.
Cyclic structure with 6 carbons. Are they the same as in benzene?
No.
No, dia hanya ada satu double bond. Okay, satu double bond. Let's say kita ada dekat sini. The 1-methyl mesti ada dekat around here juga. Okay, and then we want to change it to become 2-methyl cyclohexanamine. 2-methyl cyclohexanamine means you still got your cyclohexane. Okay. Bila cyclohexane, you still got your methyl. So let's say you keep the methyl dekat sini. Tapi at the moment, your methyl is at carbon number 2. Okay, means your amine is at carbon number
Why?
One, sebab dia adalah functional group kan. Functional group kalau amine sahaja dalam tu, so dia akan jadi parent. Tapi kalau dia ada lain pula, dia akan jadi substituents. Okay. So ini kita punya compound lah yang kita nak form. Jadi now suggest to me how are you going to do this? You first need to get rid of the double bond, right?
Yes.
To get rid of the double bond, is there any reagents from chapter 5 alkene 5.2 that involve the reactions with ammonia? Ada tak?
No.
Tak ada. Jadi kita nak kena buat apa dulu? Aim kita nak pecahkan dulu. So we have two reactions in alkene itself. One is electrophilic addition. Bila electrophilic addition, ada lagi tak double bond? Bila add?
Tak ada.
Tak ada dah, nanti hilang lah. Okay, itu satu cara. Satu lagi cara is oxidative cleavage. So oxidative cleavage, kita pun akan hilangkan double bond, tapi double bond C dengan C yang tak ada. Dia still ada tak double bond dalam produk kalau oxidative cleavage?
Okay.
Still ada, dia akan dapat C double bond O, tak sesuai pula. Okay, jadi sekarang kita tengok dekat electrophilic additions. On this carbon, the first carbon yang hold the NH2, dia ada one hydrogen at the moment. While on the second carbon, we got no hydrogen attached to it, is it?
Yes.
Betul tak?
Yes.
Okay, and then you want to keep, towards the final product, you want to keep the carbon that hold the methyl, he still got the methyl. Means kita aim nak masukkan apa dekat your carbon yang ada methyl tu? Is it heteroatoms or just hydrogen? What do you think? Kalau kita nak keepkan the methyl and add something else that is not shown on your compound in skeletal.
Hydrogen.
Hydrogen. So suppose kita nak masukkan ada hydrogen dekat sini, right?
Betul.
Okay, so now we have learned about this one rules that determine the hydrogen will be added to the carbon with the most number of hydrogen. Okay, jadi sekarang ni macam mana? Kita nak guna Markovnikov rule. Okay, tapi sekarang ni kalau kita cakap Markovnikov rule, hydrogen will be added to the carbon with the most number of hydrogen, which suggests the carbon number 1, is it? Carbon number 1 on your product, betul tak?
Yes, yes.
Okay, tapi sekarang ni, the hydrogen on your carbon number 1 remain unchanged. So are we going to follow the rule or disobey the rule?
Anti-mechanical.
Sorry? Apa
Disobey.
kena? Ya, kita akan disobey dia. Jadi kita kena pilih reagent yang disobey the Markovnikov rule. Kita tak boleh masukkan lagi hydrogen dekat dalam carbon number 1 that hold the NH2. Jadi, could you please tell me what is the reagents to be used in here?
HBr
HBr.
Yes, HBr and also hydrogen peroxide or acid peroxide lah, H2O2. Okay, bila kita react the HBr in H2O2, dia akan disobey the Markovnikov. Jadi, you are going to keep your cyclohexane and the methyl will be kept here, and instead of having hydrogen at the first carbon yang satu tu, kita akan masukkan H dekat sini. Means dekat sini pula kita akan masukkan Br, right?
Yup.
Ya. So, kita ada Br. Oh, tak boleh tunjuk H, tapi kat sini saya nak tunjuk H sebab saya nak bagi awak tak lupalah ada. Okay, sebab dia cakap 2 step. This is only 1 step. So kita 1 step away. Your aim now is to change this Br to become NH2. So once you got this Br attached to your alkene, so you ada haloalkane, right?
Yes.
What is the reagent to be used when you want to substitute your Br with a compound to become NH2 dekat situ? Kita akan react dengan
Excess NH2.
yes, excess. Is it NH2?
Ammonia.
Okay, ammonia
NH3.
excess and H3 kan. Ni hati-hati Selalu macam tu. Walaupun kat sini NH2 tapi kan kita dah buat bond. Maksudnya ada something yang kita kena keluarkan, right?
Betul.
So kita akan react dengan excess NH3. Kalau tadi we got electrophilic addition, when we substitute Br with NH2, what is the name of this reaction? What is the type of reactions involved?
Nucleophilic substitution.
Yes, thank you. We have nucleophilic substitution because we know already amine with this lone pair will be the nucleophile or electrophile?
Nucleophile.
Nucleophile. Okay, boleh tak saya nak tanya sikit? When you have this NH3, NH3 is a strong or weak nucleophile?
Weak.
When you have only lone pair, so dia adalah weak. When you have weak nucleophile, this cycloalkane, this cycloalkane pula, this haloalkane on your left here, yang bawah ni, yang ada Br tu, they got sp3 carbon kan? Betul tak? Carbon ni adalah sp3?
Yes.
Okay. Boleh tak saya tahu bila dia sp3 dia ada classes of alkyl halide. What is the class of alkyl halide you have in here?
Secondary.
Secondary. When secondary alkyl halide pair up with weak nucleophile, which mechanism are we going to proceed with? SN1 or SN2? SN1 during the first step melibatkan satu step sahaja. SN2 dia masuk terus satu step, dua step sekaligus. So bila weak nucleophile nak buat reactions dengan secondary alkyl halide, what is the mechanism to be used?
SN1. SN1.
SN1 sebab dia lemah kan. Bila dia lemah dia tak boleh nak attack directly untuk dapat produk, right?
Yes.
Okay dah tu, dah faham, ingat lagi SN1, SN2. Okay, good. And then, dia sambung soalan ni. What is, saya buat tutorial je lah hari ni, tak sempat nak masuk chapter 12. Okay, what is the product formed when 1-methyl cyclohexene, 1-methyl cyclohexene means your initial structure, is treated with hot acidified solutions of potassium permanganate. So what is the name of this reactions class? Apa dia ni? Bila react dengan potassium permanganate? Ni structure ni.
Oxidation.
Oxidations. So bila undergo reactions with oxidations, KMnO4, KH plus heat, is this part of electrophilic additions or oxidative cleavage?
Oxidative cleavage.
Okay, bila oxidative cleavage, kita nak kena buat apa dulu? Kita nak buat apa?
Cleave the double bond.
Okay, cleave the double bond. So only cleave the part yang ada double bond sahaja. 1, 2, 3 sini. Bila cleave, the number of carbon will remain or change?
Remain.
Remain. Jadi kita ada a total of 7 carbon, right? So kita ada
Yes.
1, 2, 3, 4, 5, 6, 7. Okay, on carbon number 6 here, tak kisahlah 6 ke apa, okay. Kita akan ada 1 alkyl group, right? The methyl, this one, yang in green here. So ni green. This is pink. 1, 2, 3, 4, 5, 6, 7 macam tu. Okay, and then at carbon number 1 and 1 and wait lah, kita kat mana dah? Kat carbon number, okay, sini satu. Oh, kat sini lah, kan? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Oh, kat sini, sorry. Bukan, yang ni saya dah confuse pula. Sekejap Ni hijau. Ni lah kita nak buat. Ada apa? Ada double bond, right?
Betul.
Sini ada double bond. Ya, dekat sini pun ada double bond. Okay, bila ada double bond, look at the carbon yang kita cleave tu. Ada tak hydrogen on them? In here, do we have any hydrogen on here?
Yes.
Okay, bila kita ada hydrogen, when you do the oxidative cleavage with oxidizing agent, kita nak dapatkan apa? We are going to keep the double bond and then we put O. We keep the double bond, we put O, right? Kalau ada H, apa yang kita kena buat? Nak biar je ke nak kena further react dengan something else? Kalau cheminophore. Okay, sebab dia ada satu hydrogen, dia akan available to form apa kat sini? Kalau kita biar, dia akan ada hydrogen kan?
Yes, miss.
Tapi sebab kita react dengan oxidizing agent aim dia nak masukkan O, right? Dekat mana yang
Betul.
So dekat H tu kita nak biar je jadi aldehyde or kita nak tambah oksigen jadi carboxylic acid?
Tambah O.
Tambah O.
Tambah O. So kita dapatlah carboxylic acid dekat sini. Okay?
Okay.
So kalau carboxylic acid dengan ketone in your compound, who's gonna be the family? Who's got the highest priority?
Carboxylic acid.
Carboxylic acid. So we have 1, 2, 3, 4, 5, 6, 7. So bila kita ada ketone as your apa kita panggil tu, the substituents, kita panggil dia oxo group. Could you please give me the name of this compound? 6. Apa saya cakap tadi?
6-oxo.
Apa? Cepat. 7 carbon. Seven carbon as the longest chain. Dapat apa? Cepat awak lagi tak habis kita punya tutorial.
Heptanoic acid.
Yes, heptanoic acid. Okay. Habislah. Right. Okay. Jom kita buat ni cepat. Write the reactions equations when nitrous acid HNO2 reacts with ethanamine. So ethanamine got berapa carbon?
2.
2. So kita ada CH3, CH2. Directly attached to it is an hydrogen and hydrogen. What is the class of amine we have in here? Primary. Okay, so this is a primary amine. So primary amine undergo nitrous acid test. So this nitrous acid test, they involve how many steps? Do they have 2 steps or simply 1 step? Nitrous acid. Yesterday we learned Hinsberg test got Hinsberg test is the first one. Hinsberg test kita ada berapa step?
2.
2. Okay, kalau nitrous acid nombor 2 kita ada berapa step? Ada berapa step?
1 step.
1 step only. So how are you going to write the reagent for this nitrous acid even though it states here HNO2? Can you simply use HNO2?
No.
No, you must prepare them in situ. Jadi kita kena tulis macam mana the reagent.
NaNO2,
Okay, NaNO2,
HCl,
HCl,
KCl. Lepas tu berapa degree?
0 to 5.
Yeah, 0 to 5 degrees C. This is how you write your reagent, okay, as part of the reactions. Okay, for this nitrous acid, once they undergo the reactions, dia akan dapat different product of primary, secondary and tertiary. Okay, jadi sekarang ni, during the first steps, during the nitrous acid test and primary amine, aliphatic, what kind of product to be formed? Kita first akan buat apa dulu? Bagi saya nama compound tu. Dapat nitroso ke, diazonium ke, apa dia? Cepat.
diazonium salt,
Ya, diazonium salt. Dalam diazonium salt, our aim nak dapatkan apa Ada NO ke, ada NN ke, dapat apa?
NN,
NN. So, dalam kita punya diazonium salt, you keep the carbon chain. So, you still got CH3, CH2. And then on the nitrogen's part, kita akan dapat triple bond N, right?
yes,
Okay, on the first end, you have 4 electrons surrounds the nitrogen. Means what will happen to the nitrogen? Will they still be in neutral state or they have charge now?
Charge.
Charge. Charge gonna be positive or negative if they are surrounded by only 4 valence electrons?
Positive.
Positive, good. What about the second nitrogen? The second nitrogen got only 3 bonding now at the moment, means they are left with
Lone pair.
lone pair. So no charge lah sebab dia zero. So sebab kita ada react dengan Cl juga, jadi dia akan ada Cl dekat tepi tu, okay? Ikutlah awak nak letak dekat sini ke, kat mana ke kan? So awak letaklah, saya buat kat sini, saya buat Cl got minus. So inilah your salt. Okay. Your salt at the moment, can we just leave it as it is or you need to further break them? Are they stable enough?
no,
No. Bila dia tak stable, jadi dia akan further breaks. Bila dia breaks ni, dia nak remove siapa?
remove Cl,
Remove Cl ke? Kita nak remove N2, right?
Betul.
N2 lah. Okay, maksudnya dekat part N2 ni, kita akan remove. So kita akan dapatkan benda lain dekat sini. Kita akan substitute dengan something else. Okay, masuk dekat sini je lah. Ada tak any, once kita remove this N2, we are going to get the carbocation. Is there any possible rearrangement taking place in here?
Yes.
No. Okay, so bila kita pecah, dia akan dapat 3 products. What are the 3 products yang kita akan dapat? The first one, kita akan form
alkene,
alkene. So your alkene comprises of how many carbons you have in here?
2,
So kena secure lah. Awak kena secure dah. Your C, double bond C means the rest belongs to H2, okay? This is your first product. The second one, you are going to get, give me the class of compound je kalau tak ni.
Alcohol.
alcohol,
Alcohol.
So when you have CH3, CH2, you simply substitute with OH in here. And lastly, kita akan dapat
alkene,
alkene ke? Alkene dapat dah?
Hello, alkene.
alcoholide,
Alkohol dapat dah? Haloalkane. Haloalkane kita Cl lah, jangan pergi masuk BR, kita react dengan HCl kan?
Okay.
Okay, that's your product. And then we have N-methyl methanamine. So how do you draw this N-methyl methanamine? It starts with your N. On your longest carbon chain, you have how many carbons?
1,
1, right? Okay. Lepas tu, on your N juga, you have methyl. Means the other one belongs to siapa? Lagi satu bond kita ada
hydrogen,
CH3.
hydrogen. So this is, what is the class of amine we got in here? Just now we have primary, now we have?
secondary,
secondary,
Okay, this is a secondary amine. Will secondary amine gives you the same product as in primary amine?
No.
No. Okay, so sekarang kita akan react with this NaNO2 HCl. Can I know what kind of compound to be formed when you have secondary amine undergo this nitrous acid test? Kita akan dapat,
Nitrosamine.
yes, nitroso. In nitroso, you are going to get apa dekat dalam tu? Ada apa? Tadi kita ada N triple bond, now kita ada
N double bond O.
N double bond. So kita buat dulu kat sini N, dia kena ada N legak kan? Bukan N kan? Bukan N double bond, right? Kita ada
Yes.
double bond O dekat sini. So on your end you got only 3. So ni ada lone pair, sini pun ada lone pair. Okay, lagi sini pun kita ada 2 lah lone pair kita. Jadi ada tak any charge dalam nitroso compound awak?
Tak ada.
Tak ada. So is this the only product you are going to form from these reactions?
Yes.
Yes, okay.
Yes.
So this nitroso compound, right? So dia tak minta awak observations, right? So lain lah the product dia, sama je macam ni. Okay. And then we have aniline. So aniline, we're gonna have aromatic or aliphatic amine.
Aromatic amine.
Aromatic amine. So 1, 2, 3. And so on your end, you got only hydrogen, right?
Yes.
Even though they are aromatic, do they have the class of amine? Do they belongs to any one of the 3 classes of amine?
Primary.
Ya, dia adalah primary, secondary or tertiary?
Primary.
Primary amine. So tadi pun kita ada primary, sini pun ada primary. Tapi produk dia akan dapat sama tak? Bila kita ada aromatic compound attached to it means they are more stable. So during the first study reactions tu, kita akan dapat intermediate of diazonium salt. What's the difference between diazonium salt involving alkyl group and aromatic group? In terms of their stability, who's got greater stability?
Aromatic.
Aromatic. So are they going to be further broken into alkene, alcohol and haloalkene?
Tak.
No.
Tak, dia takkan ada dah. So dia akan stop sampai sini lah. Unless you're going to further react them with siapa? Semalam kita buat apa last reactions? Apa nama reactions tu?
Hoffman's.
No, coupling. Hoffman baru nak buat amine. Ni yang
Ya, ya.
coupling tu. Tak apa, saya maafkan lagi awak lupa sekarang. Nanti dalam kelas awak tak boleh lupa dah. So kita akan stop until here only, okay? Dekat diazonium salt. Dan dia orang ni very stable. So very stable, tak perlu ada that intermediate bracket, okay?
Okay, Miss.
Okay.
Okay, next we have aniline. Again, you have this aromatic amine, okay, with nitrogen attached to it. And bear in mind, we have 2N on here. Means your hydrogen will be replaced with the 2 alkyl group, right?
Yes.
Okay, so kita ada N, satu kita ada CH2CH3 sebab dia ethyl. Satu lagi is butyl, got how many carbons?
4.
Oh, CH2, 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 CH3, methylpropute. So this is N-butyl and ethyl aniline. What is the class of amine we got in here?
Tertiary.
Tertiary amine. Okay, tertiary amine. So, undergo reactions with this NaNO2, NaNO2, HCl 025 degree C. Okay, kita akan dapat product of apa? Kita dapat apa ni kalau tertiary aromatic?
Para-isomer.
Apa?
Para-isomer.
Para-nitroso, right? Betul tak? Okay.
Yes,
So,
Miss.
okay. Untuk tertiary amine, untuk aliphatic produk lain sikit sebab dia tu tak berapa nak banyak steric effect. Jadi dia akan simply ambil satu, ambil nitroso, dapat nitroso, satu lagi dapat H. So diorang dua-dua akan dapat positive charge. Tapi sebab kita ada this aromatic amine and diorang akan buat resonance pun dalam tu. So So kita akan favor because this N got electrons on them, so they are considered as electron withdrawing group. Jadi bila electron withdrawing, dia adalah auto and para director group. Jadi kalau auto dia akan masuk sebelah ni. Tapi sekarang ni crowded tak dekat nitrogen tu?
Yeah.
Ya, so instead of dia masuk dekat auto, dia akan masuk dekat mana? Dia masuk kat mana? Kalau dia tak masuk dekat auto, dia masuk mana, Wak? Para. Dia masuk N double bond O. Okay. Okay. Right. So we'll proceed with the second part, the last part lah, face-to-face question. You need to suggest a chemical test to differentiate between these two compounds. Okay. Sekarang ni in A we have the first compound given here. What is the name of this compound? Or just give me the classes of the class of compound. Is this amine or amide ke? Beritahu saya.
Amine.
Amine. Okay, ini amine. Lagi satu. Bila dia ada C double bond O directly attached to NH2, they are amide. Okay, good. Bila dia kata test any reactions yang sebab dalam chapter 11 ni kan kita buat reactions dia pun ada observation, so they are considered as test lah. So we have Hinsberg, we have nitrous, we have bromine test. Okay, itu boleh. Even for coupling pun boleh juga sebenarnya sebab dia bagi apa nama tu kita panggil? Dia bagi observations. Okay, jadi sekarang ni what kind of test can you suggest to differentiate between these two? Boleh tak kita guna nitrous acid test macam tadi?
Tak.
Tak boleh ke? Nitrous acid. Kalau nitrous acid, okay. Nitrous acid test, Hinsberg test tu kita guna untuk apa? Untuk differentiate
Classes.
Classes of amine. Kalau amine, kita ada amine dengan amide. Jadi kalau classes of amine primary, awak dapat tak produk yang boleh bagi observations kalau aromatic amine?
Tak. Apa itu?
Tak dapat ke? Yang ni tadi. Kan kita buat aniline kan? Sama kan? So undergo nitrous acid test, kita akan dapat salt ni. Salt ni dia stable tak?
Oh, stable.
Dia bagi tak? Bila dia stable, dia boleh jadi compound lah. Ada tak observations dalam primary tu? Primary aromatic? Ada? Betul ada? Kalau ada dia punya, kalau ada observation, maksudnya dia boleh tak kita jadikan dia positive results?
Boleh.
Boleh. So basically nitrous acid ni boleh lah guna juga. Okay, sebab apa? Amide dia akan bagi positive result tak?
No.
Salt tu bagi result tak sebenarnya ni? Saya tengok dalam nota tak ada. Ada tak dia bagi results? Tak ada kan? Ada tak?
Tak ada.
Tak ada lah. So kalau tak ada, tak boleh guna lah. Walaupun nama dia test sebab dia nak juga dia ni.
Observation ke?
Observation sebab dia minta chemical test kan. So mungkin dah tak sesuai. Okay. Sebab dia boleh buat reactions lain. Kalau awak nak tunjuk, awak kena sambung. Kena buat coupling reactions. Sebab from coupling baru ada observations, right?
Yes.
Okay. Kalau you want to proceed with nitrous acid test, you must followed by coupling. Okay, so at the moment saya tak tunjuk lah sebab tadi kita dah buat banyak nitrous acid test kan. Okay, so sekarang kita tengok pula. So basically boleh guna tapi kena proceed dengan coupling sampai dapat observation. Okay, Sebab dia kata tadi this diazonium salt is very useful intermediate. Bila intermediate tak dapat lagi lah final product. Okay, apa lagi kita boleh suggest? Can we use Hinsberg test? By the way, tadi amide akan bagi negative result lah. So bolehlah guna nitrous acid. Hinsberg test boleh guna tak untuk differentiate between primary amine and amide? Boleh tak awak rasa?
Miss, yang amide tu dia primary juga ke?
Ada ke kita guna Hinsberg test untuk differentiate amide?
Tak ada.
Tak ada.
Tak
Kalau
ada.
tak ada, okay, confirm dia negative result. Kan?
Ya.
Untuk primary amine aromatic, Hinsberg test will give sebab kalau Hinsberg test dengan nitrous acid test dia lain. Hinsberg test primary ke secondary ke, dia mesti akan bagi produk yang sama untuk aliphatic dengan aromatic. Tu kita punya concern. Cuma last time dalam lecture saya just tunjuk aliphatic lah, tapi aromatic pun sama je. Okay, kalau primary amine, kita akan dapat tak observations untuk primary amine dalam Hinsberg test?
Dapat.
Dapat?
Kita dapat. So boleh tak kita guna?
Boleh.
Boleh.
Oh ya, yeah. So kita bolehlah try buat Hinsberg pula. Kita try buat Hinsberg. Kita buatlah Hinsberg dulu. So kalau Hinsberg, awak first kena buatlah, bila minta chemical test, saya ajar hari tu kena ada reactions. Okay, so reactions dia kena lukis balik. So you have these amine, okay, NH2. Okay, dalam Hinsberg test kita ada berapa steps?
2.
First you react with apa?
Access KOH.
Okay. Belum lagi. Itu dia punya reagent. Kena react dulu dengan siapa? Benzene, sulfonyl, chloride kan?
Alright.
Kalau awak nak guna ni, awak kena ingat lah dia punya compound to react dengan reagent. So this is your benzene sulfonyl chloride. Boleh juga guna SO2 saja. Then only you akan guna reagent excess KOH. Excess KOH. Bila kita buat test ni, walaupun dia ada 2 observation, awak kena provide dua-dua baru dapat full mark. Okay?
Okay.
Okay, so here we have 2 available hydrogen, right? H dengan H kan?
Yup.
Okay, the first hydrogen kita akan pair up dengan Cl, is it?
Yes.
Betul.
Lepas tu, lagi satu hydrogen kita akan pair up dengan
K plus.
OH. K plus tu spectator je.
Okay.
Okay, so kita akan remove HCl. Kalau remove HCl sahaja, okay, awak akan dapat 1 lone pair nanti. So daripada N ni, kita akan dapat 1 lone pair tambahan. So dah 2. Bila you remove lagi hydrogen, you dapat 3 lone pair. Okay, by right, sekeliling dia ada 7. Patutnya ada sampai negatif 2, right? Instead of 5.
Betul.
Okay. Tapi sekarang, bila kita remove HCl, kita akan buat bond dengan SO, right?
Betul.
Okay, so kita lukis balik. You have your benzene here, attached to it. N ni tadi, satu dah pergi buat bond dengan S, double bond O, your benzene. Okay, kat sini. So sekarang ni, awak ada 2 bond dekat N. Jadi instead of ada 3 lone pair tu, kita akan tinggal dia jadi 2 je kan?
Betul.
Okay, so dia jadi macam ni. Kalau kita tengok, keliling nitrogen should be 5 valence electron. Now you have 6. So they are left with negative charge, is it?
Yes.
Okay, jadi kita kena keep lah your lone pair. Okay, lone pair ada. So dia tinggal jadi negative charge. Kena make sure negative charge tu dekat N. So sebab tadi kita ada Okay, spectator ion kita tadi, dia pergi mana? Dia akan pair up lah dengan tu, tapi dia akan jadi ionic compound je. So K ni kita tulis balik, letaklah dekat dengan N ni. Letak atas boleh, nak letak tepi sana pun boleh. Janji dia dekat. Okay? Right. So sebab you dah remove HCl and at the same time you remove water, so dia akan dilutekan balik. So what kind of observations to be that we're going to have in here?
Clear solution.
Clear solution.
Yes. Observations kita adalah clear solution. Awak kena tulis dekat sini sebab dia ada. Ingat kalau tak ada ni tak dapat markah sebab dia sekali. Okay, lepas tu second step we have we add dengan
React
satu
with
plus.
HCl.
Yes. Do we need excess HCl or just HCl?
Just
HCl only.
Okay, HCl only. So bila kita react dengan HCl means we are going to take in the hydrogen here. Siapa yang nak ambil hydrogen? Who is capable to donate their lone pair to take the hydrogen in?
N.
Yeah, and so one of the lone pair here dia akan pair up dengan hydrogen. Means ada something yang berlaku dekat sini. So bila ada something yang berlaku, adakah kita akan remain with the clear solutions?
No.
No. So kita akan dapat
What precipitate?
yes, what precipitate. So dekat sini ada lagi tak negative charge kalau dah ada 3 bond dan 1 lone pair?
Tak ada.
Tak ada dah. So observations yang kita ada di sini is white precipitate. Boleh Hari tu saya tunjuk je dekat ni saya buat sama-sama dengan awak. Saya harap awak boleh buat jugalah. Sama-sama lukis. Alright, boleh. So bila ada benda ni, dia akan dapat positive or negative results?
Positive result.
Okay, positive result. Means for amide, sebab tak cukup ruang kat sini, for amide, kita nak kena buat juga tak macam ni?
Tak apa lu.
Kena buat. Awak kena buat juga tahu tak? Sebab dia kata, walaupun dia kata suggest a chemical test. Yes, you already mentioned the name of test is Hinsberg test and you need to provide reactions and observations for both compound that we want to differentiate. Okay.
Okay.
Alright, jadi kalau untuk amide, kita kena tak lukis balik macam ni? Maksudnya kena tunjuk tak react dengan excess KOH, benzene, sulfonic chloride, HCl?
Kena.
Kena. Tapi awak just tulislah no reactions. Bila observations, no clear solution, no white precipitate. Yang opposite. Boleh?
Okay, boleh.
Macam tu je lah. Okay. Right. So, Hinsberg test boleh. Boleh tak satu lagi, bila kita ada aromatic compound, boleh tak kita go for bromine water? Kita tahu bromine water, we want to identify aniline, right? In your compound?
Yes.
Yes.
Okay, jadi sekarang ni dalam amine yang kita ada tak aniline?
Ada.
Ada. So boleh tak dia bagi positive result when using bromine water?
Boleh.
Boleh. So awak boleh gunalah amide. Ada tak aniline?
Tak ada.
Jadi boleh tak dia bagi negative results?
Boleh.
Boleh. So kiranya boleh je lah semua ni. Tapi yang paling senang awak rasa siapa antara tiga ni?
Bromine water.
Bromine water. So whenever you have aromatic compound to differentiate with, okay, and kita kena tahulah apa the functions of the test because we know the bromine water you want to identify whether there is aniline in your compound or not. Ada positif, tak ada negatif, confirmed. Jadi kalau awak tak nak habiskan masa dan tak nak silap, better go for bromine water lah whenever you have aromatic compound. Kalau boleh lah, kalau dua-dua aromatic compound awak ada aniline, boleh ke kita buat bromine water?
Tak.
Tak sesuai. So saya nak bagi awak nampak lah macam mana kita nak check the suitability of the chemical test. Okay, jadi perlu tak lukis untuk dua-dua? Amine and amide punya reactions together with observations kalau dia minta chemical test to differentiate? Kena. Unless dia cakap suggest a chemical test, bagi tahu nama test dulu and write the reactions for only compound that give positive results. Itu tak payahlah buat dua-dua. Tapi kalau dia cakap to differentiate, yes, awak kena buat dua-dua. Okay?
Okay.
Alright. So proceed lagi yang ni. We have etanamin. So etanamin kita berapa karbon? Ethane?
2.
2. So kita ada CH3, CH2, and H2. What is the class of amine we got in here?
Primary.
Primary. Good. And then we have N-ethyl ethanamine, means the longest carbon chain of
2.
2 juga. CH3, CH2, and we have nitrogen. Okay, but then it's stated here you have another nitrogen N in here. So dekat N tu ada lagi satu tak alkyl group?
Ada.
Ada. So kita ada ethyl, so 2 carbon, and CH2, CH3. Means lagi satu belongs to
Hydrogen.
hydrogen. So kita ada lah kat sini. Okay, so you have this is primary, secondary or tertiary?
Secondary.
Okay, secondary. Can we use bromine water test to differentiate between these two?
No.
No, bromine water tak sesuai. Boleh tak kita guna nitrous acid test?
Boleh.
Boleh. Boleh tak kita guna Hinsberg test?
Boleh.
Boleh juga. So awak nak guna yang mana? Hinsberg ke nitrous?
Nitrous.
Nitrous. Okay, kita buat nitrous pula. So first tulis dulu. Name of test. Kita guna nitrous acid test. Yes. Acid test. Make sure ada observations tau. Ada tak observations untuk primary amine nitrous tu? Info tak present.
Ada N2 gas.
N2 gas tu itu observation dia. N2 gas ke kalau observations ke bubbling?
Kat dalam nota ditulis N2 gas.
N2 gas Okay, tak apa ikut nota. Nanti kalau ada apa-apa perubahan saya tanya balik. Okay, so kita buatlah. Kalau nitrous acid test ni dia lebih simple lah sebab dia tak payah banyak-banyak observations. Okay, so kita, tapi make sure awak kena ada lah, ada punya observation. NaNO2 HCl 025 degree C. Okay, sebenarnya awak bila buat nitrous acid test ni, kita tak perlu pun nak tunjuk dia intermediate tau sebenarnya. Yang tadi saya tunjuk tu sebab dapat kita dapat gambaran lah nak dapat apa. Selalunya saya akan suruh awak buat dia punya intermediate, tapi tak buat pun tak apa sebenarnya kalau minta nitrous acid test. Jadi kalau kita proceed with on the product, kita akan dapat produk apa?
Alkene.
Alkene. Dapat sama macam tadi kan yang macam kita buat tu. CH3, CH2, CH2 double bond CH2. Okay, tambah alcohol, right?
Yep.
OH dan juga
Halo alkene.
alkene. Tapi kalau ikut awak punya observations kan, ada tak observations yang kita dapat daripada 3 compound ni? Tak ada kan?
Tak ada.
Okay, so kena masuk jugalah N2. Sebab ini kan chemical test kan? So somehow observations perlu ada dalam produk, right?
Yes.
Okay, so either awak buat N2 pointing upwards macam ni nak bagi tahu gas, ataupun sekejap ni nampak. Ataupun awak boleh tulis apa? Gas, right?
Ya.
Yeah, so what is the observations kita ada kat sini? Nitrogen
gas.
release kan? Okay, nitrogen gas released. Okay, what about secondary? Kalau secondary pun kita akan undergo reactions with NaNO2, HCl dan juga 0 to 5 degree C. Okay, lepas tu bila dia buat reactions, dia akan dapat apa?
Yellow oil.
Okay, tu observation. Dia punya compound dulu. CH3, CH2 and kita dapat apa Wak? Kalau tadi kita dapat salt, lepas tu dapat 3 compound tu dengan nitrogen gas. Kalau yang ni,
Dapat nitroso compound.
nitroso compound means we have N double bond. Oh, on your end do you have charge?
No.
Oh, so letak lompat. So this is your nitroso compound. So your nitroso compound will give you observations of
Yellow oil.
yellow oil form. Okay. Dah lah, habislah. So walaupun dua-dua bagi positive result tapi sama tak dia punya product?
Tak.
Tak sama. So boleh je lah kita guna nitric acid test. Okay.
Okay.
Right. Is this the last question? Yes. Okay. So the questions ask you, when a compound with molecular formula C7H9 is treated with Hinsberg reagent and nitrous acid HNO2 respectively, the following results are obtained. Okay. Lepas tu dia bagi awak dah test kalau Hinsberg ni dia punya observations. Kalau nitrous acid test awak dapat these observations. Okay. From the observations, dia cakap draw one possible structural formula of C7H9 and write all the equations involved. Bila dia minta draw possible structural formula, nak satu je. First awak kena lukis structure dia. Apa benda C7H9N ni? At the moment dia give you only molecular formula. But they want structural formula means bukan expanded, bukan skeletal, bukan yang tu lah, sorry, structural formula yang tu. Tapi saya suruh lukis apa selalunya? Expanded saya nak ke? Tak nak. Expanded tak nak. Try untuk dapatkan skeletal. Okay, skeletal or condensed lah. Better skeletal. Okay. We know we have C7H9N. Yang saya ajar selalunya bila kata nombor dia lebih kurang, usually dia belongs to, kalau nombor dia 7 dengan 9, dekat-dekat kan. Dia apa benda ni? Banyak carbon. Kalau banyak carbon ikutkan banyak H kan? Tapi kalau nombor lebih kurang, might be ada apa kat situ. Hydrocarbon apa yang sikit? Dia ada banyak carbon tapi hydrogen dia pun sikit. Sama banyak dengan hydrogen je, dengan carbon je. You want to go for aliphatic or aromatic, do you think? When you have quite the same number.
Aromatic.
Yeah, most probably kita ada aromatic compound tapi kita belum confirm lagi sebab we learn primary, secondary and tertiary they can also be in aromatic compound or aliphatic. Jadi yang kita boleh keluarkan sekarang mungkin dia aromatic. Okay, itu kita punya possibility lah. But always check for the observations given here. When you add excess KOH, clear solutions is formed. Out of the 3 classes of amine, during the first reactions with excess KOH, who will give clear solution?
Primary.
Primary amine.
It can be either primary or
Tertiary.
tertiary. Okay. And then for the second reactions with HCl, precipitate will form. So, from clear to become precipitate. We learn clear, precipitate,
Primary.
precipitate, clear, is it?
Yes.
So we are left with only primary and tertiary or only primary, only tertiary?
Primary only.
Primary
Only
only. So kita boleh narrow down yang this compound might be primary sebab dari Hinsberg dia akan dapat primary. Okay. And then dia top up lagi, dia convince you lagi with nitrous acid test on the same compound, okay? On the same compound, bukan compound lain. When react with nitrous acid pula, dia cakap no N2 gas is released. N2 gas is released when you have primary amine, right?
Yes.
Okay, tetapi dia cakap tak ada N2 gas release. Your primary amine, it could be aromatic or aliphatic. From this nitrous acid test, it tells you that they're gonna be
In aromatic.
aromatic. So you must form a primary amine aromatic, primary aromatic amine for this C7H9N. And you need to also provide all the equations involved together with the observations given here sebab dah bagi. Masuk sekali. So clear soalan nak apa?
Okay.
Okay, so kita start lah. Because we have C7, means you first starts with your benzene ring. Okay, 1, 2, 3. Lepas tu, C ni baru 6. And then macam mana? Are we going to put another carbon on here? Baru ada N?
Ya.
Ataupun awak ada benzene? Sebab kita kena ada juga benzene. Or you got directly attached to it, to it is H. Then kita ada another, tak kisahlah, sini boleh, sini boleh, sini pun boleh, tak ada masalah. Mana pun tak apa. Kalau kata saya pilih yang ni. Which of these two do you think, Allahu Akbar, which of these two compound do you think will obey all the observations given here? You say it must be primary. Okay, both are primary, right?
Yes.
Yes.
But then, what makes it different from one another? Aliphatic got they got another chain of carbon, even it's just one carbon. Okay, untuk hold the group. Now, on your left, you have additional carbon on here, while on your right, you have no additional carbon. So we could say on the left, we have aliphatic or aromatic amine.
Aliphatic.
This one is aliphatic, okay, Wak? Sebab dia start dengan carbon kan kat situ. Okay,
Betul.
betul dia primary, but they are aliphatic. So we cannot say that these compound obey all the observations given. So tak sesuai. Ini tak sesuai. What about the other one? Can we say that this compound is good for the observations given up there? Yes.
Yes.
Okay, so inilah yang kita akan cakap our primary aromatic amine. So this is your possible structure. Bila nak bagi jawapan, janganlah lukis dua-dua. Ni kita buat justifications. Choose only one. Okay, tunjuk yang betul sahaja. Soalan minta lagi. Soalan minta write all the equations involved. Dia dah bagi observation. Perlu tak kita keluarkan dalam bentuk reaction?
Perlu.
Perlu. So kita start lah. Kita start buat Hinsberg dulu. Hinsberg test berapa steps?
1,
Hinsberg?
2.
Dua. Hinsberg ada dua ni. So buatlah. Dia tak kisah memang mana awak auto meta para tu tak ada masalah. Tapi selalunya auto dengan para lah sebab N. Okay, NH2 tapi tak ada masalah sebab awak tak belajar benda tu. Kita first boleh ke terus react dengan excess KOH?
No.
No, kita first kena react dengan apa nama compound tu?
Benzene sulfonyl chloride.
Yes, benzene sulfonyl chloride. S double bond O double bond O. We have our benzene. Kalau awak lukis benzene tu macam tu, lukislah sama, jangan buat bulat. Kalau sama lah, dia boleh je kalau nak ni. Okay, lepas tu kita akan react with excess KOH. Kita dapat salt tadi kan? Kita akan remove siapa dekat during the first step ni?
Remove hydrogen NCl.
Kita remove hydrogen ke? Kita remove dua hydrogen tu HCl dengan water kan?
Yes.
Kejap nak bagi lukis dia elok sikit. Awak susun lah dia, awak susun dia bagi lah. Kejap je awak. Tak cantik pula saya lukis. Dah lalang kan kita nak buat ni, kita buat bagi dia sekata. Macam tu. So ini kita ada metal, kita ada N H2. So nanti bila dia buat ni, dia akan dapat N on S double bond O double bond O. Tak muat. Kejap. Awak nak habis dah belajar awak. Laju betul. Kawan-kawan lain dah sampai dah sini?
Belum.
Hello.
Awak tahu kan kenapa saya laju? Tunggulah nanti saya masuk kelas. Saya tak tahu ni apa benda lah, awak tahu ke tak ni. Okay, kita ada 2 lompai, jangan lupa. On your end, we have charge or not?
Yeah.
Ada.
Ada. So kita ada negative all. Kita ada negative charge means our spectator ion K plus pun kena tulis kat area sini juga. K plus. What is the observations given? Clear solution is formed, right?
Yes.
So tulis je observations, clear solution. Okay, lepas tu kita proceed dengan next reactions with HCl. So HCl kita ada ambil hydrogen, right?
Ya.
Okay, ambil je yang tadi. Ini. Paste. Right. Jangan ada K dah, jangan ada ni dah. Sebab kita nak tambah siapa?
Hydrogen.
Hydrogen. Allah. Hydrogen. So what is the observations given there?
White precipitate form.
Okay. White precipitate. Okay. Precipitate. Ya Allah. Precipitate. Okay. Itu first lah, first reactions. Lagi satu kita kena buat untuk nitrous acid. So kalau nitrous acid, we have aniline. Aniline pula compound kita tadi lah kan. Ni metal NH2. Okay, saya tunjuk ni sebab senang kita nak tahu dia dapat produk apa. Kalau nitrous acid, we react with NaNO2 HCl 0 to 5 degree C. Okay, lepas tu sebab dia ada aromatic compound, kita akan form apa dekat sini?
Diazonium salt.
Are they stable or not stable?
Stable.
Stable. Sebab itulah observations dia cakap no. La ilaha illallah. No and 2. So boleh tak kalau kita ada primary aliphatic dengan primary aromatic, kita guna nitrous acid? Boleh tak dia dapat negative results?
Boleh.
Boleh. Sebab kalau yang aliphatic, dia akan ada N2 release kan?
Betul.
Kalau yang ni tak ada. Yang ada Cl minus. So observations kita no N2 gas released. Bila provide semua ni dapatlah markah penuh dia. Mari kita tengok markah dia berapa. Bila you bagi this, dapat satu structure ni betul. Satu. And then, sebab dia tak minta justify, so tak perlulah keluarkan tu. Tapi sebab dia minta reactions, dia bagi markah kat sini lah. When you provide this SOCl2 and SSKOH, sebab basically SSKOH dah bagi. So dia bagilah markah kat sini. But the reason dia minta awak buat these chemical equations because they want to look at the compound to be formed. Observation dah bagi tapi compound dia belum bagi kan?
Betul.
Bila compound belum bagi, markah dekat compound lah 1. Lepas tu HCl pun dah bagi, oxidation dah bagi, dapat markah dekat compound. So dah berapa dah markah kat sini?
4.
4 dah. Okay. Yes, 4. Lepas tu you further react with NaNO2 HCl 0 to 5 degrees C. Kalau ikutkan dia dah bagi belum? Dia just kata nitrous acid. Sebab awak buat prepare in situ 1 markah. Lepas tu you provide the diazonium salt that is very stable without the square bracket indicates the intermediate, you will get another mark. Sometimes 2 lah, sometimes dapat 1 je sebab sekaligus. So at most boleh dapat 6 markah, 5 to 6 marks lah regarding these questions. And it is possible for this type of questions to keluar sebabnya itulah markup untuk chapter 11 if I'm not mistaken. Maybe 5 ke 6 sebab dulu dia 7 tapi bila dia dah percentage kurang untuk exam jadi dia kurangkan sikit. Saya rasa 5 kan. So ni contoh-contoh soalan yang boleh keluar lah. So somehow kena tahulah kan reactions tu.
Betul.
Okay, dah habis dah. Awak ada apa soalan tak untuk chapter ni? Walaupun awak tak habis digest lagi tapi masa kita buat tutorial ni okey tak? Susah tak chapter ni?
Saya nak tanya.
Apa dia?
Nak tanya
Boleh. Tanya.
yang untuk resonance effect untuk determine basicity tu,
Okay.
yang part nak tahu dia EWG ataupun EDG.
Okay. So, untuk syllabus awak, EWG, dia tak banyak lah. Okay, EWG kita tak banyak untuk your syllabus. Usually dia akan guna yang most common. Macam NH2, NO2, OH macam tu. Dia bila sebut electron donating group, dia akan tend to donate sebab dia tak banyak elektron dekat dia. Maksud tak banyak tu, dia tak ada extra elektron. Sebab tu, kita usually cakap EDG ni adalah alkyl group. Because alkyl group, you got only carbon and hydrogen, right?
Yes.
And carbon at most boleh ada 4 bond sahaja. Ada tak you see any extra electrons on this carbon in terms of negative charge or lone pair?
Tak ada.
Sebab tu dia hanya ada ability to donate sahaja. Dia ada elektron tapi dia boleh bagi je sebab elektron dia berkongsi, right?
Betul.
Untuk electron withdrawing group. So untuk dia withdraw, dia kena ada the capability to attract towards themselves. Okay? In other words, electronegativity lah. Sebab kita faham maksud electronegativity is ability for the element untuk attract electrons towards itself untuk buat bond, right? Okay, so the characteristic on your electron withdrawing group supposed to have extra electron on them. And when we say extra electron, usually it is characterized by having lone pair. Sebab tu NH2, kalau kita ada NH2 ni maksudnya group yang attached lah kan. And kita akan attach to something, right?
Yes.
So kalau macam ni pun NH2 ke OH ke, dia ada lone pair. Jadi bila dia ada extra, boleh tak dia pergi tarik orang?
Boleh.
Boleh. So selalunya dia dekat group yang hujung-hujung ni 15, 16, 17 tu sebab dia banyak elektron keliling dia. Dia sendiri banyak so dia boleh tarik orang ke arah dia sebab tu dia withdraw. So okay, dari segi nak kenal EDG, EWG.
Okay, dah faham.
Okay, so bila awak nak relate dengan resonance effect, bila sebut resonance, okay, resonance is not necessarily to involve only aromatic compound. Okay, resonance ni kita belajar in last semester chapter 4. We know that it is a structure, Lewis structure. You asalnya Lewis structure ni adalah element and surrounded by berapa banyak elektron. Lepas tu kena make sure paling jauh untuk minimize repulsion. Tu maksud Lewis structure kan?
Yes.
Okay, kalau dia cukup-cukup je bond keliling dia, contoh ada F, H macam ni. Okay, dia cukup-cukup je elektron, even though they have extra electron on this F once kita distribute all the electrons, tapi sebab dia hanya ada extra electron without any other extra electron that in the forms of double bond, boleh ke dia buat another Lewis structure yang ada CH3F juga, ke dia boleh stick pada satu structure ni sahaja? Contoh,
Structure je.
satu structure je, awak ada extra betul, tapi untuk awak ada extra, contohnya awak bagi kat dia, lepas tu jadi apa? C dah bertambah-tambah kan dia punya bond. Boleh ke dia bergerak? Dia akan stuck kan, tiba-tiba jadi tak stable, dia jadi negatif lah kat sini, right?
Ya.
Jadi sekarang ni aim kita, kalau kita kata resonance tu bukan hanya ada aromatic ring, sebab awak cakap sekarang yang basicity ke apa tu kan kita nampak ni. Saya takut awak tak boleh nak beza dekat kalau ada C double bond O ke apa. So sebab tu saya ulang balik benda ni tau.
Okay.
Okay, so dia tak boleh buat sebab dia tak cukup sifat. Sebab bila kita cakap resonance structure ni, ability to move pi electron. Okay, pi electrons comes from the double bond, bukannya lone pair sahaja. Pi itu datang pada double bond awak. Multiple bond lah, bukan double. So kalau awak ada multiple bond, barulah awak akan ada sigma pi tu, ingat lagi?
Ingat.
Jadi sekarang dalam compound CH3F ni tak ada, jadi tak boleh buat resonance. Kalau kita tengok acidity dengan basicity, you ada C double bond O. Okay, asalnya OH. Bila kita remove H tu, dia akan jadi O ni ada 3 lone pair kan? Okay, ada tak extra electron dekat sini?
Ada.
Ada tak sebelah dia ada multiple bond?
Ada.
Boleh tak dia buat resonance?
Boleh.
Boleh. Okay, so ni ada resonance. Lagi satu, Allahuakbar. Kalau kita ada benzene ring, inolah let's say O yang H tu. So tinggal 3. Ada tak extra electron?
Ada.
Ada tak sebelah dia yang carbon directly attached itu ada double bond?
Ada.
Boleh tak buat resonance?
Boleh.
Okay, itu in terms of resonance lah. Awak nak tanya pasal basicity kan? Ke tak? Resonance effect untuk basicity tak?
Betul.
So tadi tu saya cerita tu sebab dia punya very basic. Okay, now kita tengok awak punya soalan. Awak nak tanya resonance effect dalam benzene ring, right? Okay. So kalau kita tengok contoh, when you have benzene ring, okay, dia ada possibility untuk buat resonance, okay, itu satu. Tetapi dia mesti ada juga something else dekat sini. Kalau basicity, we are talking about nitrogen, right?
Ya.
Okay, nitrogen. So dekat nitrogen kena ada lone pair. Maybe awak ada H ke ataupun CH3 ke, tak kisahlah. Okay, asalkan ada lone pair, sebab our aim now in basicity, you want to donate siapa? You want to donate H or you want to donate lone pair?
Lone pair.
Okay, you want to donate lone pair. Means kalau untuk donate, dia kena high electron density or low electron density untuk dia jadi sangat pemurah.
High electron density.
Ya, kena high electron density. So somehow dia akan terbalik daripada acidity. Kalau acidity, dia tak suka orang bagi dia elektron sebab nanti dia jadi susah nak sebab dalam acidity we want to remove H, right?
Ya.
Okay, tapi kalau untuk basicity kita nak donate N, donate lone pair. Untuk donate lone pair, dia suka tak orang bagi elektron kat dia? Suka. Jadi sebab dia nak kuat kat sini, jadi dia suka lah elektron pergi kat dia. Kalau acidity terbalik. Okay, itu nak faham kenapa nak kena datang kat dia. Boleh?
Okay.
Okay. Apa yang kita faham dalam resonance effect, kalau melibatkan benzene ring dengan basicity, kita tahu yang bila dia ada resonance dan tengok dekat sini, kita ada tak extra electron on the nitrogen?
Ada.
Okay, the carbon holding the nitrogen, do you have the multiple bond attached to it?
Ada.
Boleh tak kita gerakkan dia?
Boleh.
Jadi dia akan form resonance kan? And resonance tu akan bagi elektron ke N ataupun tarik dari N.
Tarik dari M.
Jadi basicity increase or decrease by having resonance?
Decrease.
Yes. Okay, itu.
Okay, faham.
Okay, kalau pula contoh awak ada compound yang sama macam ni, tiba-tiba dekat sini awak ada group metal. Okay, satu ada metal, satu lagi kita ada, sebab dia boleh datang comes together lah. Sebab satu lagi kita ada, contohnya kita ada OH. Where? OH. On OH we have lone pair. So these two, even though they are separated quite distant from the carbon bearing the NH2, okay, tapi dia ada satu yang ada elektron banyak, satu yang ada elektron cukup-cukup, right? Okay, we know CH3 is EDG or EWG.
EG.
E apa? Dengan EG je.
EDG.
EDG maksudnya dia akan bagi ke dia tarik?
Bagi.
Bagi. Kalau OH dia ada banyak elektron dekat dia. Jadi dia ada capability untuk donate or withdraw. Withdraw. Okay, betul. Resonance effect dia akan tarik. But somehow group attached to your resonance structure tu boleh tak dia mempengaruhi?
Boleh.
Boleh. So ni yang kita masuk dalam case inductive effect. Bila sebut inductive effect, dia ada dua group yang boleh effect. So untuk affect basicity, by having EDG, will they increase or decrease your basicity?
Decrease.
Increase the basicity, good. Sebab dia akan, walaupun dia ditarik, tapi dia akan provide juga. Sebab lama-lama dia kan akan pusing kan? Okay, kalau EWG, dia akan tarik, right? Dia akan increase or decrease the basicity?
Decrease.
Decrease. Itu clear?
Okay.
Okay. Lagi, mungkin awak nak tanya saya macam mana nak gerakkan resonance dalam basicity Itu nak tanya ke tak Yara?
Gerakkan tu maksudnya case resonance dia ke?
Ya, resonance structure dia. Sebab dia lain sikit. Bila dia tarik dan dia datang daripada macam just negative charge, bukan extra electron. Sebab dia melibatkan positive charge. Kalau acidity kan kita gerak, dapat bond baru kan? Yang ni kan kita akan bagi dekat ujung ni. So dia nanti jadi negative charge. Itu okay?
Okay.
Okay, right. So ada lagi soalan? Ni basically yang saya cerita ni memang dari awal sampai habis. Walaupun awak tanya yang part bawah tu je. Nak orang lain pun mungkin kalau dia segan nak tanya boleh dapat tahu juga. Ada lagi soalan regarding apa-apa pun tak apa, saya boleh jawab. Chapter lain pun boleh. Since kita ada masa, kalau tak ada apa dah, saya nak tutup kelas je. Okay, bye-bye. Assalamualaikum.
Okay, Miss. Thank you, Miss.